Well, good day to you. My name is Figa and welcome to MV Tutors. Well, we are doing the 2021 June uh, exam. This is mathematics and this is paper one. So you just wrote this a few weeks ago, really. So yeah, if you want to prepare for the next upcoming exam, then you've come to the right place. Just stick around and I'm sure you'll have some understanding at the end of this um, lesson. I don't know what to call it, maybe a tutorial, but basically we're just trying to explain the memo for this examination. But without any further ado, let's get right into it. Okay, so here we go. Now solve for x. Well, the first thing that I do is just look whenever you have a quadratic formula like this. Okay, I like to use the quadratic formula. Did I say whenever you have a quadratic formula? I meant a quadratic function. I use a quadratic formula to solve x in a quadratic function like that. So basically, the first thing I do is just put a on top there, a B there, and then a C on top of that. So that just helps me to recognize what's what. And then I know that x is equals to minus b, that's the quadratic formula, plus or minus square root of b squared minus 4ac. Okay, all this is under a square root and divided by 2a. So from here, I don't need to think about it. I just look. Minus, what's my b there? My b was minus 1, so I'll put a minus 1. Plus or minus the square root of b. b is 1. It's minus 1. Doesn't really matter whether I put it as minus or positive. Anything squared is still going to be a positive anyway. Minus 4a. a is 1. And then c minus 20. Just like that. All of this is under a square root. So divided by 2 times a is 1. Cool. Let us now bring in a calculator so that we can calculate this real quick. Calculation skills are very important, but since you're in grade 12, I'm assuming that you're already well familiar with this calculator. So that's a negative there. Open a bracket. I'll put it exactly as it is. Okay. And then let's start with the plus. And then open the square root first. And 1 squared minus 4. Open a bracket. There's a 1 there. Open another bracket. It's a minus 20. Negative 20. Close that bracket. And we can go downstairs and just put a 2. Okay, so our first answer is 5. Let's write that down. X is equals to 5. Now we need to put a negative now and see what that is going to give us. So we'll go back to our calculator, press the back button, press it until you get to where you have a plus. Nope, this side, and then delete that. Put a minus. Let's say equal. X is equals to minus 4. Minus 4, just like that. Okay, let's move on. Now we have x is equals to that. Well, this doesn't change anything. That's still gonna be my a over there. That's b, that's c. Correct to 2 decimals. Got it. So I'm just gonna substitute it back into the quadratic, which is minus b. What's my b? My b this time is minus 2. plus or minus square root of b, which is minus 2. Like I said, it really doesn't matter whether I put a minus there because it's a square. And then minus 4. A this time is 3. And then B, C is minus 6. Okay, there we go. All of this is under a square root. Okay, and all of this is going to be over 2 times a, which is 3 in this case. All right, let's bring in our calculator and then let's try to solve this real quickly. Clear that, start afresh. We have a negative outside, open the bracket. We have a negative 2, close the bracket. We'll start with the plus, put a square root sign, and then we'll have 2 squared minus 4 times 3, okay, times negative 6. There we go. Let's go downstairs. We would put 2 times 3. Well, what is that? Have it in decimal. They said 2 decimals. So we'll have 1.78. That's our first x. And then our other one, let's go back till we get to the positive there. Remove and put a negative. So we get that. Negative 1.2 decimals, 12. Negative 1.12 is equals to negative 1.12. Well, I didn't check the decimals here if it's really an 8, but you know how to round out by now, I'm sure. Right. Now let's go to the next question. Next question says, now we have this. It's an inequality. Okay, now I know what your temptation is. Your temptation is to put a square root here on both sides so that you'll have 1 x minus 1 is greater than 3. But you would be wrong to do that. You can't just do that. This is an inequality. It's not an equal sign. If it was an equal sign, then probably you could do that. But since it's an inequality, no, don't do that. So that's a wrong thing to do. Don't be tempted like that. Okay, so let's do the right thing. Okay, so the right thing here, okay, just want to do it this side. Good. So what we're going to do, the right thing to do is to say, okay, let's open that up. Let's put 2 of them side by side. That's what the square really means. Okay, and let's keep the greater than 9. And then we're going to multiply that with that. This exercise, I always do this thing where I do that so that I'm not confused. I know exactly what to do. So x times x, that's x squared. X times minus 1 is minus x. And then minus 1 times x is minus x. Minus 1 times minus 1 is plus 1. All of this is greater than 9. Okay, and then I'll have x squared minus 2x. Then I want to bring the 9 to the other side. It's going to change sign and become negative. So I'll have negative 9 my plus 1, which gives me negative 8. All of this is greater than 0. Okay, so we have a quadratic function here. Okay, and it's a positive quadratic function, so it looks like a smile like that. Okay, Then we just need to get the x-intercepts so that we know we just look at where the graph is greater than 0. We're not concerned about the turning point. We just want the x-intercepts. Okay, so we'll open two brackets, greater than 0, put x on both of them. Now we're looking for multiples of 8 that will give us -2. Okay, so we know 4 and 2 will give us -2 only if the minus is on the 4 and the plus is on the 2, then we'll get -2. Okay, so what does this tell us? That means x is equals to 4 and x is equals to -2. Well, that's great, because now what we can do is just draw a mini graph. You know, we can draw a mini graph like this real quickly. We just need a 4 and a -2. Really, that's just it that we need. Okay, and then let's say we have -2 over here, and then we have +4 over there. And since it's a positive graph, it's smiling, therefore our graph is really just like this. Goes there, passes the -4, turns somewhere, we're not concerned with where it's turning, passes -2. Okay, now we are looking for where the graph is positive, where it's greater than 0. It's greater than 0. It's greater than values of x that are greater than 0. So if we are coming from infinity, negative infinity, like that, okay, if we are coming from negative infinity like that, okay, what that is telling us is that, well, from negative infinity to -2, that's where the graph is positive. Okay, or you can look at it like it's from 2 going that way to negative infinity. Also, now when we get to -2 and we continue like this, the graph is now at the bottom side. Okay, so that's not what we're looking for. The graph is negative. But now when we look at values from 4 going to infinity, the graph is on the positive side. What does that mean? Let me demonstrate it like this. Let's say you have a line, you draw a line from after 4. If I draw a line after 4, do you see that the line touches the graph on the positive side? If I draw it before 4, okay, those are values of x, it touches the graph on the negative side. Likewise, if I draw a line there, it touches the graph on the negative side, but on the other side of -2 touches the graph on the positive side. Okay, so then as our final answer, put values of x. We put values of x once again, like that. We'll put this sign, we'll put the number on the left, which is 4 this time, and the number on the right is infinity. Okay, that's it. Well, another way you can write this is you can say, well, x is an element from negative infinity to -2. And for this one, x is an element from 4 to positive infinity. Just like that. That's your answer. Okay, let's do question number 1.1.4 now. So there we go. 1.1.4, we have 1.1.4, we have 2 square root of x plus 6. Okay, plus 2, that's going to be equals to x. All right, so the first thing we want to do is get rid of this plus 2, so we'll take it to the other side. This one remains exactly the same, so we'll have x minus 2 this side, and then we need to get rid of this square root, so we'll square both sides. Okay, just like that. We leaving this 2 here because I think it will become just too much. Imagine squaring a fraction, so we don't want that, so we'd rather leave it there. But in essence, you can divide by that 2 if you want. It will just complicate our lives. So that 2 squared is gonna be 4, and then you'll have a square root. Squared is just the function under the square root. This side, unfortunately, we have to open 2 brackets. It's always easier to do it this way, but you can also do it the short way. Now, always do this exercise. It helps, especially under exam stress, not to make silly mistakes and forget what to multiply with what. So this side will have 4x plus 4 times 6 is 24. That's going to be equals to x times x is x squared, x times minus 2 minus 2ax minus 2 times x is minus 2x plus 2 times 2 is 4. Right, so what do we want to do now? Okay, let's take everything to one side, like terms with like terms. So minus 2, that's minus 4x, and then I want to bring that x to the other side. So that is going to change sign and become minus 4x as well. And then I'll keep this plus 4 here, and then take 24 to the other side. It changes sign, it becomes minus 24. Okay, then finally I have x squared minus 4 minus 4, that's minus 8x, and then plus 4 minus 24, that's minus 20. Okay, so now we need to factorize this so that we can solve for x. Generally, I just like to put it in the quadratic function because it makes things a bit quicker. But you know, let's just do it the other method that is also quicker. That is much quicker, but you know, can get confusing for a lot of you. But let's do it for the sake of time. So we want multiples of 20 that can give us an 8. All right, so I'm thinking 10 and 2. Now we want to get minus 8, so the one that has to be negative is the bigger number, and the bigger number is 10, so we'll put the negative on the 10. This allows us to then conclude that x is equals to 10 or x is equals to minus 2. Okay, well, you can check if you want. You can check your answers, because normally if you have a or, it means that it can be either of these answers. But if you really want to be sure, just take the numbers and put them in the equation. Like here, let's put a 10 here, so that you'll have 10 plus 6 is 16. So 16, square root of 16 is 4. So 4 times 2 is 8. 8 plus 2 is 10. That's correct, because you substitute 10 here, there's an x. So that one's correct, definitely. Let's mark it correct. Now let's try this minus 2. So if you put minus 2 in x here, you'll get minus 2 plus 6, which gives you 4. Square root of 4 is 2. 2 times 2 is 4 plus 2, that's 6, is equals to 6 is equals to minus 2. That's not true. So it means that we cannot have an answer of x cannot be equal to minus 2. Okay, let's do it like that. All right, so that completes it. Now it says here, solve simultaneously for x and y. We are given these equations over here. We have 4x plus y is equals to 2. And then, oh, we got a square here. Okay, so what I'm going to do is that I'm going to name this one equation number 1. And this one will be equation number 2. Okay, so let us manipulate these equations. So I'm going to take equation number 1 and make y the subject of the formula. So that's equation number 1. Y is equals to 2 minus 4x, right? Now what I want to do is take 1 and put it into equation number 1 and put it into equation number 2. So what that looks like is that we're gonna have a 4x, which is equation number 2, plus where there's a y, I'll substitute equation number 1. Oh, sorry guys, I'm sneezing. So it should be y squared, so it's 2 minus 4x. This should be squared and make it equals to 8, right? Now all we need to do is just solve this, do some mathematical gymnastics. So first we're gonna, you guessed it, open 2 brackets. 4x 2 minus 4x. Don't forget the equals to 8, very important. Okay, so we can continue here. That's gonna multiply with that and that, this with that and that. So 2 times 2, that's 4. 2 times negative 4 is negative 8x. And the same here, negative 4x times 2 is negative 8x. And then negative 4 times negative 4 is positive 16x squared. That's equals to 8. Okay, so let's put this in order. Start with 16x squared negative 8, negative 8, that's also 16. Wow. Okay, negative 16x. Oh, and then I got a positive 4 over there, 4x. And then I have a positive 4. That's the only number. And then I want to bring the 8 to the other side, so it changes sign, becomes negative 8. And then this is 16x squared minus 16 plus 4 is minus 12x. And then plus 4 minus 8 is minus 4. Is equals to x. Well, this is too complicated for me to do by process of 2 brackets. So I'm just gonna do the quadratic formula, because the quadratic formula always gives the right answer. Never wrong. Okay, it's easier to make a mistake with two brackets, but not here. That's B and that's C. Okay, this takes the guesswork out. So minus B, what's B? It's minus 12. It's plus or minus square root. B is 12 squared minus 4. A is 16. And then C is minus 4. Okay. Over 2A. So 2 times 16. Now we gotta put that in a calculator. Let's grab our calculator right over there. Open that, put a negative, open a bracket, put another negative, put a 12, close that. And then let's start with the plus. Nope, not multiply. Plus. Open the square root. 12 squared minus 4 times 16 times negative 4. Like that. And then we call downstairs. We'd have 2 times 16. Just like that. Oh, wow. Okay, so our first answer is 1. Well, I have the calculator. Let me go check. Let's change that. Make it a negative. Okay. So it's positive 1 and negative a quarter. Thank you so much, calculator. Okay. So those are our final answers then. We have x is equals to 1 or x is equals to negative a quarter. Well, you can do the check, can always substitute. Oh wait, we're not done yet, because these are simultaneous equations. We need to solve for y. So for y, we'll use that equation, y. Okay, so it was y is equals to, forgot that equation, 2 minus 4x. 2 minus 4x. Okay, so let's start with our first our y when x is 1. So we'll have 2 minus 4 times 1. And then this side we'll have a y where it's 2 minus 4, and our x is minus 1 over 4. So our y this side, well, I don't even want to think of it. I'll just use a calculator. So it's 2 minus 4. Oh, that's it. It's minus 2. Okay, let's do that side. 2 minus 4. Let's open that bracket and fraction, put a negative 1 on top, and then put a 4 at the bottom. No, it's not time to close the bracket yet. Must go to the side first, then you can close. 3. Okay, so thank you, calculator. You know, I could have done this in my head. 2 minus 4 is minus 2. And then this side, 2 minus 1. 2 minus minus 1 is 3. Okay. Let's put it all there. So when x is 1, y is minus 2. When x is a quarter, y is 3. Okay, do we have another question? Oh yes, we do. We have this question over here. If it is given that determine the numerical value of, okay, so this is the vision right here that we are trying to solve, but we gotta start it small. Let's start with this. So we have 2x times 3y is equals to 24 to the power 6. Okay, so the tricky part here is to rewrite 24 in its what do I call it, in its exponents. Okay, so if you think of 24, you can rewrite 24, and the bases that we want to use is 2 and 3. Okay, so 24 can be rewritten as 2 to the power 3 times 3. 2 to the power 3 is 8, and then 8 times 3 is 24, right? And then all of this is to the power 6. Okay, so now what are we going to have? We're going to have 2x times 3y is actually equals to, what's 3 times 6? It's 18. Yeah, so 2 to the power 18 times 3 to the power 6. From that, then we can conclude that x is actually equals to 18, and then y is equals to 6. Exponents are equal to each other when the bases are equal to each other. Cool. And then remember, the vision was to solve x minus y. So x, we have 18 minus 6, which is equals to 12 at the end. Ladies and gentlemen, that was a long question, but it was worth 24 marks. I hope you understood everything, but in the event you didn't, you can contact me through my website, www.mvtutors.co.za, and then book a session, a tutorial session. I would love to tutor you one-on-one. Well, thank you so much.
Hello everyone and welcome to MV Tutors. I'm Tolo and I'll be looking at question 2 of the supplementary exam that was written in June this year. Alrighty, let's get into it. So, consider the quadratic sequence. Okay, we have 72, 100, 120, 132. Now we need to determine the nth term of the quadratic sequence. Alrighty, so not bad, guys. I think you guys first were introduced to the quadratic sequence in grade 11. So this shouldn't be bad at all. Okay, so first you're going to determine the first difference. Okay, so 100 minus 72, that should be 28. Yes. Okay, then 120 minus 100, that's 20. And 132 minus 20, that is 12. Okay, and then we get the second difference. So 20 minus 28, that is negative 8. And 12 minus 20, that is negative 8 as well. Okay, guys. So when you get here, then you need to remember the general formula or the general term formula for a quadratic sequence. It's actually an squared plus bn plus c. So if you substitute 1 in there, you're going to get a plus b plus c. If you substitute 2, you're going to get, if you substitute 2 on the n, okay, the n term, so you're going to get 4a plus 2b plus c. And if you substitute 3, you're going to get 9a plus 3b plus c. And if you're going to get the difference between the two, I'm just going to look at this first. So I'm going to get 3a plus b. Here, I'm going to get 5a plus b. And if I look at the difference between these two again, I'm actually going to get 2a. Okay, so why did I do all of that? Because you're going to get your 2a and you're going to make it equal to negative 8. Okay, then you're going to take your 3a plus b and equate it to 28. And lastly, you're going to take a plus b plus c and equate it to 72. And in that case, you'll determine a, b, and c and then substitute it in there to finally get your nth term quadratic sequence equation. Okay, so this is what 2.1.1. Okay, so then I'm going to say 2a is equal to negative 8. So a will be equal to negative 4. Then I have 3a plus b is equal to 28. Okay, so a is negative 4. So 3 times negative 4 is negative 12. Okay, and if I take negative 12 to the other side, it's going to be positive 12. So I get b to be equal to 40. Yes, 40. All right, let me see. Everything is still on track. Yes. All right, and then finally, a plus b plus c, that will be equal to 72. So I have a as negative 4, b as 40, and c, which I am looking for. So c minus 4 plus 40, that's actually 36. And if I take 36 to the other side, it's actually 72 minus 36. And 72 minus 36 is 36. Okay, so I have a, b, and c. Now I can write down my final term equation. So I have negative 4n squared plus 40n plus 36. And guys, now when you get here, you don't celebrate just yet. You are gonna have a look if your equation works. If I substitute in n is equal to 1, will I get 72? If I substitute n is equal to 3, will I get 120? Okay, so I have negative 4. I'm gonna substitute 3 and squared plus 40 times 3 plus 36. If this does not equal 120, I'm in trouble. Okay, we're good. Let me just check with the first term. Okay, you need to check, guys. Checking is important because you don't want to do all this work and then you get it wrong. So yes, our equation works, which is absolutely great. Now let's get to 2.1.2. It says a term in the quadratic sequence is equal to the 12th term of the sequence of first differences. Determine the position of this term in the quadratic sequence. Okay, what are they saying? They're saying a term in this quadratic sequence is equal to the 12th term of the first difference. So this is the first difference. Okay, that is the second difference. So here, I'm going to have to look for what the 12th term is, because they're saying a term in the quadratic sequence is equal to the 12th term of this first difference. So once I get this T12 of the first difference, it's going to be a value, right? And I'm going to have to determine that value on the quadratic sequence. Okay, I hope you understood me there. So 2, 1, 2. But firstly, I need to determine the nth term for this first difference. The first difference is actually the arithmetic series. So for that, I know that A plus n minus 1 times D. What is A? A is actually 28. And D is actually minus 8. I can actually substitute in the n value because it's 12. Oh, can reduce it there. Okay, so n is actually 12, which makes life a bit easier. Okay, so yeah, I can plug all of this in the calculator so that I can determine it quickly instead of calculating in my mind. So 28 plus 11 times negative 8. I'm actually getting negative 60. Okay, so I know that the 12th term is negative 60. Okay, now there's a negative 60 here. Okay, on the quadratic sequence. Now I need to know where is it negative 60. Okay. So I have my term formula, which was, sorry guys, my throat. Okay, sorry about that. 4n squared plus 40n plus 36. And, okay, that term is equal to minus 60, okay? Now I need to determine the n value. Which number is it? That's what they asked for, right? They said determine the quadratic sequence is equal to the 12th term of the sequence of the first differences. Determine the position of this term in the quadratic sequence. So yes, we are calculating for n, okay? So I have negative 4n squared plus 40n. Okay, I'm going to take 60 to the left side, okay? So 36 plus 60, it's going to be 96. All right. You can decide at this point you're going to use the quadratic sequence. I just want to simplify this. I am going to divide by 4 throughout, or rather negative 4. So if I divide by negative 4, I'm going to get n squared here. 40 divided by negative 4 will be negative 10n. And 96 divided by negative 4, I don't know. I should know, but I do not. So what is 96 divided by 4? Okay, it's 24. All right, so negative 24 is equal to 0. Now I need to look at the factors of 24 and see what is it that will give me 10. Okay, so I have 1 and 24, definitely not. 2 and 12, a possibility. 4 and 6, also a possibility. 3 and 8, no. So it could either be one of these two. Now, if I take the bigger value, if I make this 12 negative, so negative 12 plus 2 will give me 10. But negative 6 plus 2 plus 4 is going to give me negative 2. So yeah, actually this is what I'll be using. So I have n, 2 and 12, negative, positive. Okay, so ultimately either n is equal to negative 2 or n is equal to 12. We already said that n cannot be negative, nor can it be a fraction. So your answer is 12, the 12th term. And if you're not sure, take this 12th term, plug it into the equation. It has to give you negative 60. Okay. Now, determine the maximum value of the quadratic sequence. I'm just going to write on the side. So 2, 1, 3. the maximum value of the quadratic sequence. The quadratic sequence, guys, remember the term formula is actually negative 4n squared plus 40n. Is it plus 36? Yes. Plus 36. This negative tells you that you have a sad face parabola, but as sad as it is, the maximum value is actually here, the turning point of your parabola, okay? And they want this maximum value, okay? So if it's a turning point, remember when you're looking for the x value for the turning point, you're actually going to use this equation, minus b over 2a. Okay, so b is 40 in this case, and a is negative 4. Okay, so we have 40 over 8, which is equal to 5. Now, once you get this 5, you're going to have to substitute it in the term formula. So x actually should be n, because in this case we have n's, we don't have x's. And instead of y, we have tn. So I'm going to substitute 5 in there. So I have minus 4, 5 squared, plus 40 times 5, plus 36. And I'm going to plug all of this in the calculator just to save time. Okay, so I have negative 4 times 5 squared, and then plus 40 times 5 plus 36, and that value is 136. Okay, and yeah, it was 136, né? It was. That is the maximum value of the quadratic sequence. And if you were to continue with it, actually you would see, let's go this side. Okay, there's no space. But yeah. Okay, so basically if you wanted to see if it's actually 136, okay, we have 72, 100, 120, 132, okay? Then we had 28, 20, 12. Okay, so if I was going to get minus 8 here, it would be 4. And the next term to get 4, it will be 136. Okay, so we see 136. But if we continued further, okay, so 4 minus 8, that's actually minus 4. And 136 minus 4, that's actually 132. Okay, so you see this is the maximum. Okay, because now from 132, we're going to go back to 120 and 100 and 72 and whatever. And then the 12th term was going to end, it was going to end up being what? Minus 60 if we went further. Okay, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Eventually, we're going to get to minus 60. Okay, but we can see 136 is the maximum. Now, 2.1.4, it says determine the maximum value of the sequence. Okay, so we have minus 23, 5, 25, 37. Okay, so again, we're going to get the first difference. So minus 23, for us to get to 5, we're going to add 28. So 28 minus 23 is 5. And then from 5 to 25, we are going to add 20. And then for us to get to 37, so 7 minus 5 is 2. That's 12. Similar to that. Okay, so definitely we know that we have minus 8 here. And they're saying we must get the maximum value of the sequence. So I'm just going to continue with it, guys. So I know after 12, I must get 4, and then I must get minus 4. So 37 plus 4, that's actually going to be 41. And then 41 minus 4 has 37. So I know that it's actually going to be 41. Okay, so that's my answer. So the maximum is 41. Okay, 41. We are almost there. Okay, the last question. Consider the sequence minus 11, 2 sine 3x, 15. Determine the values of x in the interval 0 degrees to 90 degrees for which the sequence will be arithmetic. Okay, so 2, 2. Okay, let's look again at the values. I have negative 11. Okay, then I have 2 sine 3x. Okay, and the last, well, not really the last, but 15. Okay, so they told me it's an arithmetic series. So it means that the difference, remember whatever difference you get here, it's actually going to be equal. Okay, so the first one, we take the second term and minus the first term, which is going to end up being plus 11. We're going to take the third term minus the second term. And these values must be equal because D is equal throughout. That's just what happens with an arithmetic series. So I have 2 sine 3x plus 11 is equal to 15 minus 2 sine 3x. And then I'm just going to put sine x or sine 3x to one side to the left and the others to the right. So I have 2 sine 3x plus 2 sine 3x. That'll be 4 sine 3x. And I have 15 minus 11. That is 4. So eventually I have sine 3x is equal to 1. Okay. Now if I want 3x, it's actually going to be equal to sine, yeah, basically. And if you remember on your sine graph, actually looks something like that. 90 is actually where you have 1. Okay, so I know that 3x is equal to 90. So 90 is actually like my reference angle. So because we're dealing with sine, okay, sine is positive on the first and the second quadrant. Okay, so I would have 3x is equal to my reference angle plus 360k, where k is an element of integers. Let's just go back to the question. What do they want before I go far? Determine the values of x in this interval. Okay, so we're looking for x in that interval. Let's not forget the interval. This is our domain. Okay. Now, if we work this out, if I divide by 3, because I'm looking for x, 90 divided by 3 is actually 30. And 360 divided by 3 is 120. Okay. If I were to substitute in a k value of negative 1, okay. If I were to substitute in a value of negative 1, what would my x be? Okay, I would have 30 minus 120, which will be negative 90. Okay, so this is not part of this domain they've given us, so that doesn't work. So if I have k is equal to 0, then x would be equal to 30 degrees. Okay, this is part of it, that's fine. If I had k is equal to 1, then it would mean that x is equal to 30 plus 120, which is equal to 150. So it's outside of the interval. And in that case, then x is actually equal to 30 degrees. And that is what will make the sequence arithmetic. So that is for the first quadrant, right? If we have this case here. Like I said, sign is positive on the first quadrant. Now the second quadrant, it's actually 180 minus the angle. Okay, plus 360k, where k is an element of integers. So integers basically meaning I could have negative values or positive values, but just not fractions. All right, so if you look closely at this, guys, 180 minus 90 is actually 90 plus 360k. And this whole thing is actually the same as that. So I'll get the same answer. X will be equal to 30, and that's where we end it. All right. Thank you so much for tuning in. If you have any questions, please do comment below. And yeah, until next time. Hello everyone, and welcome to MV Tutors. I'm Solo, and I'll be looking at question 3 with you guys. All right, so if R is equal to 1 over 5 and A is equal to 2000, determine Tn, the general term of the series. Okay guys, so immediately when I saw R, I knew that I'm dealing with a geometric series. Okay, so if that's the case, if I'm going to write the general term, let me see. Okay, if I'm going to write the general term, 3, 1, 1, I know the general term equation is A times R to the power n minus 1. So they already gave us A, which is 2000, and they gave us R, which is 1, 5. One thing about R, if it's a fraction, I know that my series or geometric series is actually converging. If it was more than 1, then it would be diverging. But anyway, 3, 1, 2, now they want me to determine the 7th term. Okay, that's not so bad. So in the place of n, now we have 7. So again, 2000, and I have 1 over 5, 7 minus 1. So it's actually 2000 times 1 over 5 to the power 6. Okay, so we definitely need the calculator to determine what that answer is going to be. So I have 2000 times 1 over 5 to the power 6, and that is 16 over 125. Yeah, 125, which is 0,128. Okay, or if they want you to round off to 2 decimal places, 0,13, but I think this would be the preferred answer. All right, now 3, 1, 3. Which term of the series will have a value of 16 over 15,625? Okay, so now we are looking for n, basically. So, okay, 3, 1, 3. So now the Tn, which is 2000, 1 over 5, n minus 1. So that value of Tn is actually 16 over 15,625. Okay, so firstly, I am going to take this 2000 to the other side. Okay, so I'm left with 1 over 5, n minus 1 is equal to, so I'm dividing by that, so it'll be 16 over 15,625 times 2000. Okay, and now guys, I will have to use logs in this case to actually solve this question. So then I will have n minus 1 is equal to log, my base will be 1 over 5, and I'll have 16 over 15625 times 2000. Okay, and then finally my n will actually be equal to whatever answer I get there, which I'm going to calculate now, plus 1. Okay, so let us get the calculator and determine what that value is. So I have log, okay, and I have 1 over 5. That's actually 0.2. But anyway, let's write it as we have it. And then we have 16 all over 15,625 times 2000. And that answer is 9. Ah, it's a nice answer. Okay. In this case, guys, we have number of terms. Okay? You cannot get a fraction. You can't say you have 5,5 terms. It has to be a whole number. Okay? And it also has to be positive. You can't get negative 5 terms. What does that even mean? So ultimately, your n has to be a whole number, a natural number, and it must be positive. Okay, so 10 is the answer. Alrighty, and then what do we have? 3.2. Consider the geometric series where the sum of the terms, however many they are, give you 27. So, I mean, it's from 1 to infinity. Okay, so yeah, it is equal to 27. And then the sum of the first 3 terms is equal to 26. Okay, now they want us to calculate the value of the constant ratio of the series. Okay, let us digest this a bit. So, we are saying the sum to infinity. If you forgot, remember at the end of your question paper, you have the formula sheet. They will give you the equation for the sum to infinity, which is a1 minus r. Okay, and they told us that the sum to infinity is actually 27. Okay, so if I were to get a, which is the first term, that is equal to 27 times 1 minus r. Then they told us the sum of the first 3 terms. So this sum here just means if you have t1 plus term 2 plus term 3, that is actually equal to 26. Okay, so the sum of the first 3 terms, that is equal to 26. And what is the sum equation for the geometric series? Okay, or sequence. It's actually, let me just, no, I don't think I remember it. Let me not lie. Okay, it's actually a1 minus r to the power n all over 1 minus r. Okay, so what I can do, okay, so 26 basically, I can say 1 minus r, and then a 1 minus r, and because it's 3 terms, your n is going to be 3. Okay, so I can then get a again because I want to actually equate the a's together. I thought of substituting a in there, but let me just make a the subject of the formula. Okay, so then I have 26 1 minus r all over 1 minus r cubed is equal to a. Okay, so I have a this side and I have a this side, so I can equate them. All right, and then we have one unknown that we can actually determine. So I have 27 1 minus r is equal to 26 1 minus r all over 1 minus r cubed. Okay, I am going to multiply the denominator to the left side, okay? I don't want fractions, basically. So I have 27, 1 minus r times 1 minus r cubed is equal to 26, 1 minus r. And there, guys, I see that I can actually divide these two. And then I'm left with 1 minus r cubed is equal to 26 or 27 times. Okay, so now I'm going to take 27 to the other side. Okay, so that I just have my unknown. So I have 26 over 27. And then just move it up a bit. And then I have negative r cubed is actually 26 over 27 minus 1. Okay, then I have r cubed. Yeah, let me just take the negative to that side, or get rid of the negative rather. So then I have 1 minus 26 over 27, and r will be that whole term cubed. So 1 minus 26 over 27, and let us get the answer. Okay, so I have 1 minus 26 all over 27, and that is a third. Great. Yes, a third. Awesome. It's a converging series, okay? That is how we were actually able to determine the sum to infinity being 27. That works for converging series. All right, guys, so we are done with question 3. Yeah, see you next time.
Welcome back. Here we are. Let's start again. Welcome back. Well, we are now on question number 4. My name is Figa, and welcome to MV Tutors. Well, let's get right into it. This is a very short question with 10 marks only. All right, so it says the lines x plus 1 and minus x minus 7 are the axes of symmetry of the function that. This is a standard hyperbole where this represents the asymptote and that one as well. This is the asymptote on the y, and that's the asymptote on the x. Okay, let me just write it here because they both share it. Okay, these are the asymptotes. Well, I'm assuming you already know this anyway, since you're in metric and you have been studying. But anyway, let's get right into it. What's the question? Show that P is equals to 4 and Q is equals to minus 3. Well, what we're gonna do here is that we're just gonna solve it from first principle. So what we're gonna do is that if these are asymptotes, remember asymptotes, so this is a positive gradient, so it's a line going like that, and this one is a negative gradient, so it goes like that. Okay, so now where they meet, okay, where they meet right there, that's where you also have your asymptotes. So let me just demonstrate that. First, let me take this a bit down. Okay, so first of all, what we're gonna have is that we're gonna have this asymptote passing the x, and then we're gonna have this asymptote passing the y. Okay, so the reds are the asymptotes, and they all meet over there. So to solve then P and Q, we have to equate the equations with the equations of these lines. Okay, so let's do that then. So we have x plus 1 is equals to minus x minus 7, and then we're just gonna solve this. Okay, we'll put x's on one side and numbers on the other side. So let's do this. X, when I take this one, it changes sign, it becomes positive, is equals to minus 7. When I take this one to the other side, it becomes minus 1. So then I have 2x is equals to minus 7 minus 1 is minus 8. So x is minus 4. Okay, so just remember that when it comes to p over here, we always take the opposite sign when it comes to the x. But let's just solve everything. What we have solved there is half the coordinate. Okay, so we know that that coordinate has an x value of 4. Now we need to solve the y counterpart of it. We can use any of these equations really. So let's take this one, x plus 1. So we have minus 4 plus 1, which gives us minus 3. So that is our y value. Okay, y is equals to that. So our y is minus 3, like that. So that's our y value. Okay, so what is this telling us then? We can therefore conclude that actually, indeed, P is equals to 4, because you take the opposite sign for P. If you know the rules for asymptotes, we solved it to be negative, but we take the opposite. And then when it comes to Q, you take it exactly as it is. It's minus 3, so it stays as minus 3. Okay, I hope you understood that, but in the event that you didn't, I would love to tutor you in these matters. So contact me. Go to my website, www.mvtutors.co.za, and book a session over there. Well, we will now attempt doing question number 4.2 right there. Like that. Okay, so it says show that P is equals to 4 and Q is minus 3. All right, let's just put together everything we have about this function. We know that this function is minus 2 divided by x, and then we have a plus 4 because P is 4. So instead of P, I'll put the 4 that P is, and then Q is minus 3, like that. Okay, and then what else do we know? We know that if you want the y intercept, you say let x equals 0. Likewise, when you want the x intercept, you say let y equal 0. So the one we're gonna take is this one, because it's the one we need for this question. So let's do that. So that means we have a 0 over there. The first thing I'm gonna do is take the 3 to the other side, so that I have 3. Let me bring down this. I need more space. So that I'll have 3 is equals to minus 2 all over x plus 4. So what I want to do now is just put brackets there. Okay, and multiply both sides with this bracket, because I really just want to get rid of the fraction. Okay, so that allows me to cancel that, and then I'm left with minus 2 And this side, I just need to multiply that 3 in, so that I'll have 3x plus 12. Okay, and then we need to do just some more mathematical gymnastics. So then I'll leave the 3 this side, 3x this side. I'll take the 12 to the other side. I'll have minus 12 minus 2. And then I want to get rid then of my 3. Divide both sides by 3. If these 3's cancel each other, I'm left with x. And that's going to be equals to minus 12 minus 2 is minus 14. Divided by 3. Okay, so I'm interested on what minus 14 times 3 is, because I think I'm gonna need a calculator for this. What's 14 divided by 3? I want it in decimal. Okay, so that's like 4.7 minus 4.7. Okay, that's cool. Thank you so much. So we have solved our x-intercept. Good. We're done with question 4.2 rather. Let's go to 4.3. 4.3 says sketch the graph of f, clearly label all intercepts. So here we need all intercepts with the axis and the asymptotes. They also want to see asymptotes. So there's 2 asymptotes here, so 2 marks there. There's 2 intercepts, so probably 2 marks over there. Okay, so we have the x-intercept already. Let's just quickly solve the y-intercept. Okay, so in solving the y-intercept, remember we said we let x equal 0. So then we'll have y. Let me use a different color because this might confuse you. We'll have y is equals to minus 2 over, where there's an x, we put a 0, plus 4 minus 3. So this is going to be 2 over 4, which is like a half, minus 3. Well, you know what? I'm not even going to bother doing it in my head. Just bring in a calculator. So I have a fraction and it's -1. Go downstairs, put a 2 there. Go to the side, put minus 3. Okay. Minus 7 over 2, which is minus 3.5. Thank you. It's minus 3.5. Okay, cool. So now we have our y-intercept. To draw the graph then, this is what I'll need. I'll need this. Let's start with the axis, the normal Cartesian plane axis. Okay, which is a straight line. Oh, but before that, let me put a grid just so that we have a perspective. Okay, so I'll put it like that. And from there to there. Now it's like I need more negative. I need more negative, so I'll make it longer this side. Okay, so there what we have is -1, -2, -3, -4, -5, -1, -2, -3, -4, -5. 1, 2, 3. I'll just have it up to 3 here. Okay, so the first thing that you always want to start with is your asymptote. Okay, so we know P is equals to 4. So the P, okay, let's start with the Q1 because I feel like the Q1 is much easier. You see where Q is? So if you ignore this, is equals to Y, which means that y is equals to -3 is our equation, and for this one then is x is equals to 4. Oh, no, it's equals to -4. P is 4 because you always take the opposite, so x is equals to -4 for your equation. Okay, so y is equals to -3. That's the one we draw over here. Okay, so it's like this. Passes -3. Okay, and this is y is equals to -3. Why is it y? Because it crosses the y. And then this other one, it's gonna be x is equals to -4. Why is it x? Because it passes the x Cartesian plane. All right. Now, what we know then, therefore, is that, so they wanted to see our intercept, our asymptotes there. They also wanted to see our intercepts. Fortunately, we have our intercepts over here. This one is for x, so x is minus 4.7. 4.7 would be somewhere there. Okay, and then the y is minus 3.5. 3.5 would be somewhere there. Okay, so now we can draw our graph. Okay, let's make the line a bit thicker. So it passes 4.7, so we need to make sure it passes there, turns around and goes all the way there. Remember, it's a negative graph. Okay, negative graph is on the second and the fourth quadrants, like that. And what makes it a negative graph is basically that number there. If this number is negative, then it's a negative graph. If this number is this -2 is positive, then it's a positive. The way you can remember this is like this. You know, if it's a positive graph, let me just do a quick sketch for you. If it's a positive graph, then you have positive, then you have positive, so it's between the positives and then opposite that. Okay, and then if it's negative, then it's, you know, the other one. Okay, but you get the picture. Anyway, here they wanted to see the intercept, so we're just gonna put 0 and what was this, -4.7, and here no, this one is 3.5, my bad, it's -3.5, it's passing -3.5. Then you get the mark if you do that. This side it's 4.7 and 0, like that. Okay, so all of this is for 4 marks. And then you can also name your asymptotes. This one is, it's passing the y, so it's y is equals to -3. This one is passing the x, so it's x is equals to -4. That's it. I hope you understood, but if anything confused you, you know what to do. I would love to tutor you. Okay, thank you. Well, hello there. We are still doing the 2021 June mathematics exam. Welcome. My name is Figa and I am MV Tutors. All right, so let's get right into it. What we have here is that we have a sketch below an f of x. That's that. I can see it's been shown, it's negative. Cool. G of x is the line, it's shown, there it is, that's cool. A and B are the x-intercepts of f. Okay, so if they want us to calculate it, you know, we say let y equals 0 to get those x-intercepts. And then C is the turning point of F. Okay, thank you so much for letting me know of that. Let's read the questions. So the first question is calculate the coordinates of a, wow, they want me to calculate the turning points. Okay, let's start right here. We are going then to say the y is equals to minus 2x squared plus 4x plus 16. Okay, so remember to get the x-intercept, we say let y equals 0. That means where there's y, we put a 0. So we'll put 0 this side, and we'll put the rest minus 2x squared plus 4x plus 16. Now we need to solve for x. Well, I usually just go to the quadratic formula. So that's minus b plus or minus the square root of b squared minus 4ac. I'm sure you know this equation by head now. I mean, we use it so much in mathematics. So we're just going to do some mathematical gymnastics, so to speak, here. Now, when I do this, this helps me a lot to write A on top there, B on there, and then C. I no longer need to think about it because I've identified my variables. So B is, I just read it off, B is 4 there, it's positive 4. Okay, plus or minus 4 squared minus 4 times negative 2, which that's A, and then C is 16. Okay, it's all under a square root. Go underneath there, we have 2 times A is minus 2. So I'm just gonna bring out a calculator real quick. Just one of them, thank you. Okay, so put that negative, put it exactly as it is, except here you can only put a plus and first. So it's squared minus 4, open the bracket, we've got a negative 2, close the bracket, open another one, put a 16 right there, close it, go downstairs, put a 2, open a bracket, negative 2, close the bracket. Minus 2. Okay, while you're still here, let me just go back, change that plus into a minus. Oh, I've forgotten the other one. Was it minus 2? This one's 4. Thank you so much. So x is equals to minus 2 and x is equals to 4. All right, so that's A. So A, just to complete this question, A is the one with minus 2. It's on the negative side. You can see on the graph there. So it's minus 2 and 0. Because remember, coordinates are always given in x and y form. So if you just solve the x and leave it here, your answer is incomplete. It's 4 and 0. We need to identify them like that. Cool. Let's go to the next question then. It says, determine the coordinates of C, the turning point of F. Okay, so coordinates, turning point, it's not that hectic. So turning point, normally to get a turning point, take a look at this. You're still getting an x value of it, right? but you are only just interested on this part of it, this one. This part of it, of the quadratic equation, gives you the turning point. Okay, so let me just rewrite it here. Let's say the turning point, the x value of the turning point is given by minus b over 2a. Okay, well, there are many ways to get the x. You can also just bisect a and b, the x values of a and b, which is 2 or 4, 2 and 4, and then get the middle of it. But I just want to show you this method. Okay, so here you'd say minus b, there's b, so minus b is minus 4 over 2 times a. What's a? It's minus 2. There we go. So we can get then that 4 divided by 4, it's negative 4 divided by negative 4, which gives me a 1. Okay, so that just gives you the x value. But even if we were using these values here, to get the bisection of it, you would say minus 2 plus 4 divided by 2. Okay, so this would give you minus 2 plus 4 gives you 2 over 2, gives you 1. But this is just the x value, so this is an x value. These are two ways to solve the x value. You still need to substitute it back into the equation to get the actual. So all we found, remember a coordinate is x and y. All we found right now is just the x, and we know the x is 1. Now we need to find the y component. To find the y component, we need to go back to the original equation and substitute where there's an x, we'll substitute. So it's f of x. Where there's an x, we'll substitute 1. And the equation is minus 2. Put a 1 there. And it's squared. Really doesn't matter considering it's a 1. And then we got a 4 and a 1 and a plus 16. I'm just gonna put this in a calculator. I'm sorry, I cannot calculate this in my head. Why do I have 2 of these? I just want 1. Let's delete this one. Yeah, that's it. Behave now. Good. So now I'm gonna have me minus 2. Why is my I don't like that the entire platform is showing it, this entire platform here. But anyway, let's just continue. So we have minus 2 plus 4 plus 16. That gives me 18. Thank you so much. 18. So my y value is 18. So I'll put 18 over there. So 1 and 18. Cool. So we're done with our turning point. Then it says write down the range of f. Remember, the range has to do this is now 5.3. The range has to do with the y values. Okay, so we're gonna say we're gonna put y, put this sign, and then, well, we can start with the top one. Now that we know that this point is 1 and 18, that's x value, that's the y value. We can put 18 2, and it goes all the way down to negative infinity. Or you can write this like this. Y is an element of 18 to negative infinity. That's it. Cool. Right, here we are. Let's do question 5.4 now. It says the graph of h of x is, okay, I see that, has a maximum value of 15 and x is equals to 2. Determine the values of p and q. Okay, so what's happening here? These are just shifts. Okay, so I had written here, now I have rubbed it, but we know that the c value here is 1 and 18. We have solved that. So let's say 1 is over here, so that's 1, and then we have 2 over here. Okay, and then that's 18 over there, so we've got 18 here, and then let's say maybe 15 is over here. So the new point, this graph has shifted and it's moved to the turning point is at 2 and 15, which is over there, but it's still the same graph. It still does that and does that. Okay, it's just shifted down here. So what has happened actually here, let's write this down this side. Now if you look, let's start with the value of p. What do we know about p? We know p is a horizontal shift. It's horizontal shift. Okay, and then we know that q is a vertical shift. Okay, so that's a shift on the y-axis. Okay, so p, what we know is that p, this graph is shifted to the right. Any shift to the right, it means it's a negative shift. So it shifted from 1, so we have 1 minus 2, that becomes that's a minus 1. So p is minus 1, shifted from 1 to 2. It's a negative, it's a shift to the right, so it's negative 1. q, however, shifted from 18 to 15. Okay, and 18 minus 15 minus 15, that's gonna be equals to 3. But remember, with a vertical shift, if it shifts down, then the number has to be negative, so it's a negative 3. Actually, this is the more correct answer. Okay, let's go to question 5.5. Where are we? 5.5. So 5.5, it says determine the equation of g of x, or the inverse of g, in the form y. So with inverses, we know that actually when it comes to inverses, I'll just rewrite this, 5.5, y becomes x and x becomes y. That's the general nature of inverses. So we're talking about g here. So let's go grab the equation of g. It's 2x plus 4. So the equation of g is such that its y is equals 2x plus 4. All right, so remember with inverse, and this is g of x. With inverse, then with the inverse, so what we do is we swap. So x becomes y and y becomes x, just like this. Now all we need to do is mathematical gymnastics, where we have to make y, the subject of the formula. So what I'm going to do is that I'm going to take the 4 to the other side, so it's x minus 4, okay, is equals to 2y, and then I'll divide both sides by 2, so that I'll have, therefore, my y is equals to x minus 4 divided by 2. If you want to simplify this further, you can just say x over 2 minus what's 4 over 2? It's 2. It's up to you, or you could leave it in that form above. It's okay still. Okay, now let us go to question number 5.6. So 5.6 says, for which values of x will the inverse times that be equal to 0? So they are saying the inverse times g of x times g of x equals to 0. All right, for us to get this, either g of x is equals to 0 or the inverse is equals to 0, or we have this scenario here, then we get 0 there and 0 there. So what we have to do is, let's take this first condition. We have to say g, the inverse must equal 0. And then what's the formula for the inverse? There, we solved it. We said, I'll take the top one, over 2 must equal 0. So now we need to solve for x. So we multiply by 2 to the other side, or both sides rather, to get rid of the fraction, to get rid of the 2. Multiply 2 on both sides, then we'll have x minus 4 is equals to 0. So x is equals to 4. That's our first solution. Our second solution is when g of x now is equals to 0. So what's our formula for g of x? It's this one, we have it there, and it is 2x plus 4 is equals to 0. So we take 4 to the other side, it changes sign, it becomes minus 4. Divide both sides by 2, and then we'll have that x is actually equals to minus, what's 4 divided by 2? It's 2, minus 2. So these are our two answers. We have two answers for this question, that one and that one. Okay, so that will give you the full 2 marks. Well, such little marks for such a long question. They are very stingy with their marks in this exam, I'll tell you that. Now 5.7 says p of x is equals to f of x plus k. Determine the values of k for which p and g will not intersect. So first we have to understand what's happening. We're back at this graph now. Okay, the values of k. So what they are saying is that p of x and g must not intersect. So p has to do with the f. So let me do this. This is g of x. We can see g of x is a straight line. So we want a point where f of x is no longer touching g of x. Okay, situation like this. Okay, so what does that mean? It means that we can equate this for where they meet and then the values where they meet, the lower values, it's where the graph of what was it? Was it P? I think it was P. Yes, the graph of P is not going to intersect. You see, anywhere above, if this graph is above this point, it's going to touch. See, it touches it there, touches it again there. So anywhere above the graph of G, okay, anywhere above the graph of G, which is this graph over here, anywhere above it, it's gonna touch, always gonna touch. But anywhere below it, it's not gonna touch. So this is really just a shift. Okay, we want to know how many units must this graph, the G or the P rather, or the G must it shift down in order so that it doesn't intersect with this graph. So this just means that we need to find the intersection. Okay, and you know already, to find the intersection, we're gonna have to take P, okay, P of X, and equate it to G of X. All right, so P of X is just F of X as we given there. P of X, let me write it for simplicity. This is F of X plus K. Okay, now we can start substitution. What is F of X? So I need to scroll up. Oh no, I'll just grab it from here. F of X is minus 2x squared plus 4x plus 16. Oh my goodness, having to always go up there. It's minus 2x squared plus 4x. Was it plus 16 or minus 16? Remember, it's plus 16, so I'm correct. So all we're gonna do is then just add this plus k like that, equate it to G of X. What is G of X? We have G of X here, it's 2x plus 4, but let's go confirm before it's 2x plus 4. That's right, that's correct. So we're doing this systematically. Now we'll just bring everything to one side before I explain further what's going to happen. So we'll have minus 2x squared plus 4x, and then I want to bring this 2x to the other side. It becomes minus 2x plus 16. Then I want to bring this 4 to the other side. It becomes minus 4, and then plus k. That's equals to 0. And finally, we have 2x squared plus, oh, what's 4 minus 2? 4 minus 2 is just a 2x. And then what's 16 minus 4? It's just plus 12. So minus 4 is, and then we have plus k. That's equals to 0. Now, pay close attention to what happens now. We're going to go back to the discriminant, or rather we'll go back to the quadratic function. Now what we are interested on is just this part of the quadratic function. Oh, quadratic function is so useful. This is what we call the discriminant. Okay, so, and it's b squared minus 4ac. This is what we call a discriminant, and the symbol of a discriminant is just a triangle. Okay, so now let's go back to our graph over here. This point, we are looking for values of k where the discriminant rather is going to be less than 0. So these are the roots we are talking about now. Whenever you see this k thing, so we're talking about a root where the discriminant is less than 0. Okay, so what is our, that's still gonna be our a, that's b, and then that is c. 12 plus k is gonna be c. All right, so we're just gonna say b squared is 2 squared minus 4 times a, which is minus 2, and then c, remember c is 12 plus k. Okay, so the discriminant must be less than 0. Okay, then we're gonna do just some mathematical gymnastics. 2 squared is 4, and then minus 4 times 2, minus 2 is plus 8, and then in brackets we're left with 12 plus k less than 0, and then let's just multiply that in before we combine things. So 4 stays as it is. 8 times 12, my goodness, I need a calculator for that. 12 times 8, 96. Okay, so that's 96 plus 8k. It's less than 0. Now, continuing with our gymnastics, I'm sure you can see what's going on. 4 plus 96 is 100. I take it to the other side. I'll be left with 8k is less than negative 100. And then to get k must then be negative 100 over 8. Okay, and that makes sense that it should be negative because it's a shift on the negative side. Well, that's the end of the question. If there's something you didn't understand, particularly this last question, do contact me. I'll be happy to be your tutor. You can book me to be your tutor or my website, which is www.mvtutors.co.za. Well, ciao for now.
Hello everyone and welcome to MV Tutors. I'm Tsulu and I'll be looking at question 6 with you guys. Yeah, we're looking at the function of, what is this function? Exponential function. Okay, cool. So, given the function of g, which is equal to 3 to the power x, write down the equation of the inverse of g in the form y is equal to. Okay, that shouldn't be so bad. All right, 6, 1, 1. We actually have y is equal to 3 to the power x. Now, whenever we're looking for the inverse, we're just going to swap the x and the y. So we're going to have x is equal to 3 to the power y. But you know that we want to always make y the subject of the formula. And to do that, we're going to use logs. Okay, so if y is going to be the subject of the formula, I'm going to have log. My base will be the 3 and x there. Okay, if you don't understand how that was obtained, you could just say log x is equal to log 3 to the power y, and you would know that whenever you have an exponent, you can actually take it down. Okay, so you would have log x is equal to y log 3, and because you want y alone, you would then have log x over log 3, and to simplify that, the 1 in the denominator, the 3 that becomes your base, and in your numerator, it just becomes that. Okay, so that's the long way of doing it. So whichever way is understandable for you, use it. All right, then 6.2. Now they say point 611 lies on h. Okay, so this function h is 3 to the power x minus 4. Let me just make it a bit bigger. Okay, so we have a function 3 to the power x minus 4 plus 2. Okay, I hope that you recognize some things here. Okay, if it's x minus 4, this is a horizontal shift. But where did it shift? If it's a negative, it actually shifted right. Okay, so it's actually 4 units to the right. Okay, that is, they took the original function, which is g, okay, the function of g, and they shifted 4 units to the right. Then when you have this constant here, that's actually a vertical shift, okay, and that represents 2 units up, okay. The positive tells you that it's a vertical shift to the top or up. Okay, if it was negative, it would have been down. All right, cool. So those are things that you should recognize. Now they say the graph of h is translated to form g. So we need to write down the coordinates of the image of P on G. Okay, so this is, now we're taking h and we're taking it back to G. Okay, so now if I'm taking it back to G, instead of having 4 units to the right, I want to subtract that 4. Okay, sorry, not to subtract it. I want to get rid of that negative 4 so that I have just x. Okay, so now I'm gonna have to go 4 units to the left in order to get rid of that negative 4 and be left with x. And then to get rid of this 2, I will have to go 2 units down. Okay, in order for me to have this 2 removed and just have my function g, which is 3 to the power x. So what will the coordinates be if I do that? All right, so just make it a bit smaller. Okay, so now I have 6.1.2. So remember, initially I had P, which was 6 and 11. And now I want that image of P. So image of P, I'll just say P dash. Okay, so with the X, we said it's going to be 4 units to the left. Okay, so it's actually going to be 6 minus 4, which is 2. And then 2 units down, right? We had plus 2, now we're going to have to subtract 2. So we're going to say 11 minus 2, which is 9. And that will be your answer. All right. Now, what are they telling us? So sketched is the graph of the function f, which is 2 to the power x plus p. Remember, the p is a horizontal shift, guys. Okay, horizontal shift. And then q is a vertical shift. Now there's a point called t, which has the coordinate 3, 16. It is a point on f, and the asymptote of f is minus 16. Okay, now they want us to determine the values of p and q. Okay, from here I can already determine what q is. Why? Because q is literally going to be the asymptote. Okay, and they already gave us the asymptote, which is minus 16. Okay, so q, so originally we have this graph. Okay, it passes 1, and it's just y is equal to 2 to the power x. That was the original graph where there was no vertical shift. Okay, so q in this case would have been 0. But now we took this graph and we went sorry, 16 units down, okay, and landed up on negative 16. So in this case, Q, okay, the 6.2, Q will be equal to negative 16. Okay, that is the vertical shift we saw. And now we're going to have to look for the horizontal shift P. Okay, and this point T here will assist us because we really don't know. Maybe T was originally there. Okay, and we need to determine now this horizontal shift, what that value is. Okay, so we're going to take our equation. I'm just going to put y there. Y is equal to 2 to the power x plus p minus 16 because we already determined what q is. And then I'm going to take that point t, the values of it, and substitute it in this equation. So in the place of y, I will have 16. And in the place of x, I will have 3. So my only unknown is literally p. Okay, so now we can work that one out. So I'm going to take 16 to the other side, and I have 32. And I have 2 to the power 3 plus p. Okay, I could use logs to get what p is, but I recognize that 32 can be written in the form of 2 to the power something. Okay, I can have 2 as a base. And if I say 2 to the power 5, that actually gives me 32. Then I have 2 to the power 3 plus p. And you know that if you have the same base, then you can equate the powers, or the exponents rather. So if this base is the same, you can equate the exponents. And then now I can get p. So p, that'll be 5 minus 3, which is equal to 2. And there we go. We have q, and then we have p. Okay, and I think that is the end of question 6. It was, yeah, short and sweet. I hope you learned something. Enjoy the rest of your day. Hello everyone, welcome back to MB Tutors. I'm Tulu and I'll be looking at question 7 with you guys. Alright, let's get started. So, an amount of 10,000 Rand was invested for 4 years, earning interest at R% per annum, compounded quarterly. At the end of the 4 years, the total amount in the account was 13,080 Rand. Determine the value of R. Okay, guys, this is a straightforward compounding question. Okay, it's not like an annuity. It's just you're going to use your normal equation where you have A is equal to P 1 plus I to the power n. So if you look at this, an amount of 10,000 was invested. Okay, so I know that P, so I like writing down what my variables are equal to before plugging them in. So I know that P is 10,000 Rand because that is what was invested. I know N is 4 years, ne? But because the interest is compounded quarterly, I'm going to multiply that by 4 to get the number of quarters. So I have 16 quarters over that entire period. All right, and then at the end of the 4 years, what was accrued at the end was 13,080 Rand. Okay, and now we need to determine the value of R. So I'm going to first determine I, which is the interest, and then I'll get R. Okay, you're like, how, what's the difference? R is just that value. I is the percentage. Okay, that's the difference. All right, so let us work it out. Okay, so yeah, using my equation here, I'm gonna have 1380 is actually equal to 10,000. Okay, and then I have 1 plus, so the interest, because it's quarterly, I'm going to divide it by 4, and n, because it was 4 years, you multiply it by 4, I'm just going to put the 16. All right, so now we're trying to get that interest rate. So 1380, I'm going to divide by 10,000. Okay, so I've gotten rid of the 10,000. I also want to get rid of the 16. So I'm going to take the root of 16. And this side, for me to get rid of it, I also need to put it there. So I have 1 plus the interest rate over 4. Okay, so those two will cancel. Then I'm left with 1 plus I over 4. I'm going to take the 1 to the other side. Okay, so I still have my 16 there, 13,080, 10,000. Then I'm subtracting the 1. Okay, so I have subtracted the 1. Then I'm left with I over 4. Okay, to get rid of that 4, I need to multiply by 4. I hope I have not lost you guys. What I'm just doing here is making I the subject of the formula. I would say at a matric level, you should be able to do that. I just did it in many steps in one. Okay. All right. You could have done it little by little, meaning you just say 13,080 divided by 10,000, put it in the calculator, and then you do the root of 16, get the answer. Then you subtract 1, get the answer, then multiply by 4, get the answer. I just like putting everything at once. Why? Because my answer won't be watered down. What I mean by watered down is I won't, every time you do a calculation, you're rounding up to 2 decimal places and you're putting in the whole value. So you are losing some values as you go along the calculation. So at the end, your answer might not exactly be the same as the one given in the memo, but it's more or less the same. So I don't want to lose any of those values. I just want to put everything once in the calculator and really hope that what I did was correct. Because imagine while making I the subject of the formula, I actually messed up somewhere. That would be a tragedy. So, and this for me, it saves time. So do whatever it is that will save you time. Okay. 2, 3. Ooh, no. 10,000. Not 100,000. Okay. We're taking that value, subtracting 1, and we're multiplying everything by 4. Okay. So we are getting 0. Oh my goodness. I forgot that answer. 0.06 something. I forgot that the calculator disappears as soon as I start writing. 0.068. Yeah. Let me just say 0.06769. 6769. But I want a percentage. Okay, so I'm going to multiply that by 100. And what is that? So that value, so 1, 2. Okay, so I'm going to get 6.77%. Okay, guys, that is I. They asked for R. Okay, so R is actually just going to be 6.77. All right. Yeah, I hope that was clear. Yeah. Okay, now we have a businesswoman who deposited 9,000 Rand into an account at the end of January 2014. Okay, end of January 2014. She continued to make monthly deposits of 9,000 Rand at the end of each month up to the end of December 2018. So if I go from the end of Jan to the end of December, that's 12 months. Okay. Now the account earned interest at a rate of 7.5% per annum compounded monthly. Okay, let's just write down what we know. Just going to write that on the side. This side. So this person, this businesswoman, is putting in 9,000 Rand per month. Okay. The period in which she put it in, it went from 2014 to 2018. So that's 4 years. Okay. But because she's putting it in monthly, I'm going to have to take, no, guys, it's not 4 years. I have 2014, 2015, 2016, 2017, 2018. It's 5 years. 5 full years. Okay, so it's 5 years. And if I'm going to take those years into months, it's going to be 5 times 12, which is 60. So 60 months. Okay, the account earned interest at a rate of 7.5% per annum compounded monthly. So whatever the compounding is done, if it's annually, it's just divide by 1. If it's monthly, divide by 12. Quarterly, divide by 4. Semi-annually, divide by 2. Hey, whatever they give you, just divide by that. Okay. So yes, now the first question. Calculate how much money was in the account immediately after 6 deposits had been made. Okay, guys, this is an annuity. Okay, you're not just taking a lump sum and putting it in the account and leaving it to gain interest and then taking it out. If you had a lump sum going on, you would use this equation. This equation is for lump sums. But if you are going to have an annuity, that is something that you are doing on a regular basis. Okay, so it's either monthly, either yearly, quarterly, whatever. Okay, if you are taking a loan and you have to pay it back, that's your present value annuity. Okay, because you're getting the money at present, that's the loan, and then you're paying back over time. So you're going to use the present value annuity. But if you are investing, that is a future value annuity because you are looking forward to that amount, that whole lump sum, after so many terms, after however long. Okay, so if it's a future value annuity, it normally deals with investments. If it's a present value annuity, loans. As long as you're getting the money today and then you're paying it over time, monthly, annually, semi-annually, quarterly, whatever, that is a present value annuity. If you're saving periodically and getting the money later, that is a future value annuity. So I hope you won't confuse the two because you do get the, what do you call this? You get the formulas in the formula sheet. I don't want you to be using the wrong formula unnecessarily and losing marks unnecessarily. So we've already established it's an annuity, and the type of annuity, it's a future value annuity. Okay, so instead of P, we normally put an X there. In the equation, you'll get X. Okay, then you have this equation, brackets, 1 times I, and you have N minus 1, and you're going to divide by your interest. Okay, yes, so X, that is your monthly amounts that you're going to put in. Okay, just making sure that I have the right equation. Yes, so the X there will be substituted by 9,000. Okay, and then you have your interest there, which was 7.5% divided by 12. I know some people work it out first and, put that worked out value. I just want to put things as they are. Okay, I don't want to water down anything. And then N would be 60. They even gave it to you. They said after 60 deposits had been made. So you didn't really need to determine that. But it's always good practice to determine it. And then we subtract by 1. And all of that will be over 7.5% over 12. So you're going to just chuck all of this in the calculator and see. Okay, so we have 9,000. Okay, and in our big bracket, okay, 1 plus 7.5% over 12, okay, to the power 60 minus 1, okay, and then that is all over 7.5% divided by 12. And we have our answer there. Ooh, I'm going to have to cram it. 652-743-95. Okay, 652-743-95. Seven, 4, 3, 9, 5, ne? Yeah. Okay, so yeah, that is the amount of money she made at the end of those 5 years. Good for her. Okay, now 7.2.2, it's this. The businesswoman left the amount, okay, this amount, 652,743.95. She left it for a further in months in the account. The interest rate remained unchanged and no further payments were made. The total interest earned over the entire investment period was 190,214 Rand and 14 cents. And now they say determine the value of N. Okay, so now we have a lump sum. It's left in the account. It's gaining interest every month. Okay, it is a lump sum. We are done with the annuity. I hope you recognize that. Now we're dealing with the lump sum. And if you're going to deal with the lump sum, this equation would be applicable. Okay, and this is what we'll be looking for. Cool. Now, what is what? So you put in this money, 652,743. So that is pretty much your P. Okay. What is A? What is I? They said the interest remained the same. So we still have 7,5 divided by 12. But what is A, guys? They told us that the total interest earned over the entire investment period was 190,214 Rand and 14 cents. This is the interest earned over the entire investment period. Okay, so that was for that 5 years. Okay, so remember this person was putting in 9,000 Rand times 60. That is the amount that she put in. And they're telling us that the interest she earned, the total interest, was actually 190, 214 and 14 cents. So basically, at the end of it all, total interest earned over the entire investment period, yeah, we're looking at everything she has put in. Okay, no, actually, let me do it like this. This is everything she has put in. Okay, you need to know what that amount is. Okay, and then this was just for the 5 years. Okay, then we're going to determine from this what the actual interest was for those 5 years. Okay, so what is 9,000 times 60? I think it's going to be 540,000. So we have 9,000 times 60. So yes, that's 540,000. Okay, 540,000. This is the amount she put in overall. Actually, for the entire investment, that's everything that she put in. Okay, now what was the interest gained over that time? Okay, yeah. Where's my pen? Okay, so this is what she put in, and then in those 5 years, this was the 652 minus the 540,000. Okay, so if I were to subtract that, 540 from the 652,000, that would have been the interest gained for the 5 years. Okay, but now they're telling us that the interest earned over the entire investment period is actually 190. Okay, so then how are you going to get your A? Because A is representative of the money, after everything is done, basically that'll be your A. Okay, that'll be the amount at the end. Okay, so let's just then have a look. All right. So, yeah. Okay. Yeah, so we actually don't even need to get this interest here. Now that I think about it, you can calculate it for interest's sake. Excuse the pun. But yeah, so 652,743,95 minus 540,000. So basically, no, it's something I did wrong. 652,743. Yes, 540,000. So basically, over the 5 years, she earned 112,743,95. Okay, that's the interest she gained over the 5 years. But now the overall interest that she gained over the entire investment period, that is the 190. Okay, and if you want your value for A, okay, the value for A, which I had put there previously and erased it, it's actually going to be the 540 plus the 190, 214,14. That is the value of A. That's basically what she's going to get at the end of everything. Okay, and I hope that makes sense. She was putting in 9,000 Rand per month for 5 years. The amount that she put in there was 540,000. That's it. Remember, A is equal to P plus I. Okay, let me put it that way. Yeah, it's actually P plus I in simple terms. Okay, so she put in 540,000, which is the P initially. Okay, and then the interest that she earned over that time was the 190,214,14. If they wanted to know the interest over that 5-year period, that is that, but they didn't ask us for it. Okay, so now we have 540 plus 190,214,14, and that will be equal to, so we have 540, 1, 2, 3, plus 190,214,14, and that is 730. 730,214,14. Okay, so we have our A, and now we can finally calculate. Okay, so 7.2. I know I've written everywhere, but I hope you guys are following. Okay, 1 plus I to the power n. Okay, so A, we worked it out. 730,214,14. Okay, and okay, we're looking for n. Before I even write the values, I'm just going to make n the subject of the formula so that at the end we can just substitute everything. Okay, so I will have A over P is equal to 1 plus I. Remember that I is divided by 12. N. Okay, so now I'm going to use my logs. Okay, so I want n, right? So n will be equal to log the base, this being the base. So 1 plus the interest, which is 7. Okay, I'm not substituting yet. Let me just relax myself. Okay, multiplied by A over P. All right, now that I have that, I can put in the values and we can get our answer. All right, so I have log. So I have 1 plus 7.5% over 12. Okay, and then A over P. So A, I forgot that amount, but P, okay, let's just go get it. A is 730. 730, 2, 1, no, where am I writing it? 730, 214, 14. And what is P? We already determined what P is. That's the amount she ended up getting at the end of 5 years, which is 652. 652,743,95. Okay. Yeah. And let us work out what the answer is. Okay. I actually want to get the unwatered down value. So it's 9479. Okay. 9479. Okay, 9479. Okay, great. Now we can calculate properly and get N. Okay, so we have log. Whew, what a loaded one. 1 plus 7.5% all over 12. Okay, close the brackets. And then we have A over P. So A was 730, 214, 14. And at the end, at the bottom here, we have 652, 743, 9479. Okay, and that's it. Huh, nice. Of course, your N has to be a whole number. Okay, you can't get, okay, you would like for it to be a whole number. But yeah, you can get like 18.5 or whatever. Okay, but months, yes, everything is in months, so we're gonna get 18 months. Okay, but you would like to have whole numbers, ideally. Okay, so yeah, I think that marks the end of the question. So we have determined the value of N, and we are done with question 7. I hope you learned something. Please do comment below if you have any questions, queries. If you feel like you didn't understand something that you'd want to be explained again, yeah, please let us know. Thank you.
Welcome to MV Tutors. My name is Figa and we are doing the 2021 June exam. Okay, so now we are on question number 8. All right, let's get right into it. It says determine f1 of x from first principles if it is given that f of x is 3x squared. So the first thing that we need to know is f1 of x from first principle. What is that? So that is just nothing but the limit as h tends to 0 of f of x plus h minus f of x, okay, divided by h. Okay, so what does this mean? It means we must substitute x plus h on the equation. So the equation that we have is f of x is actually 3x squared. So what we're going to do now, in order for us to do f1 of x, is that we're going to have the limit as h turns to 0, and then for fx plus h we are going to put 3, open the bracket, where there's x we put x plus h, okay, and it's squared there, and then it's minus f of x, which is already 3x squared, and then we're gonna divide this whole thing by h. So now we have to expand this. Let me give myself some space. There we go. Right, let's get back there. So let's just continue. Now when it comes to actually expanding this thing, I prefer to open two brackets. I know you can do it in one bracket using the your knowledge, but I find that, you know, under exam pressure, it's actually easier to make a mistake. So to avoid that, rather do things the long way, a guaranteed way. So this way I know I'm gonna multiply x by x, and I actually put these things. You know, this is what I'm doing now. They help under exam pressure, because now I know that all I have to do is just follow these steps. Okay, so let's continue. So we have the limit. Fortunately, we have to write this thing all the time. So we have a 3 there. X times x, the first blue line, is x squared. The next one is x times h, which gives us plus xh. The next one is h times x, which gives us xh again. And then the last one is h times h, which gives us a positive h squared. We close the bracket, minus 3x squared. So everything else remains the same. So we'll have an h over there. Okay, let's give ourselves more space. Okay, and then we continue. You have to write this over and over again for as long as you are simplifying. So here, what I'm gonna do here is get rid of the bracket again. That means I multiply the 3 there, there, and there. Okay, you are in metric, you can combine this in one scoop. So let's do this. Let's say 3 times x squared is 3x squared plus, okay, 3 times xh is 3xh, okay, 3xh plus another 3xh. I should have actually combined these, but it's fine. For simplicity's sake, we'll leave it like that. Okay, so we get that minus 3x squared. And divide this by h. Okay, now I need you to see what's going to happen now as we simplify this thing. We're gonna say 3x, which is, I'm gonna tick it, this one minus 3x squared, which is combining variables that are like or like terms. So this and that, the ones I've ticked, they become 0. And then I'm gonna add that and that. So then I'm gonna have 3x squared minus 3x squared is 0, so I don't need to write it. 3xh plus 3xh is 3 plus 3 equals 6xh plus 3h squared, and all of this should be divided by h. I'm sure you can see now that something is happening. Okay, so what we're gonna do now is that we're gonna factorize by taking h out. Okay, and then we'll be left with 6x plus 3h. Okay, and all of this is divided by h. Okay, let's give ourselves more space again. And then what's gonna happen now is that the h's are gonna cancel each other. Then I'm left with 6x plus h. So what I want to do at this point is actually okay, let me just write it so that you don't say I skipped steps and you didn't understand what I did. So now I have 6x plus 3h. Now I can substitute 0 where there's an h, and it's over there. So when I substitute, I don't need to write the limit anymore. I'll just write 6x plus 3h, and the h we substitute 0. My final answer is 6x. That's it. That's it. Done with this question. Let's go check what the next question is. And that's 5 marks. The next question is 8.2.1. f of x, determine f1 of x if f of x is that. So the first thing that you want to do when you're doing this kind of question is that you really just want to simplify everything into one line. You don't want fractions, so we need to rewrite that in one line. So that's x squared minus 3, it's already simple, plus 9. When we write this x squared, that's a fraction, when you bring it on top, it just becomes minus 2 as opposed to a positive 2 when it's a denominator. When it's a numerator, it becomes minus 2. Okay, now we can differentiate. Remember, in differentiating, we bring the number down, that the exponent, which is 2, and then we write the x2, and then we subtract 1 from it. Okay, now this one doesn't have a variable. Okay, so we cannot differentiate a number, so I'm just gonna leave it as minus 0. And then this one, remember, we bring down the number first, so the number is actually minus 2, and then we write the 9x minus 2 exactly as it is, and then we subtract a 1 from it. Okay, and then from there we can simplify. This is just 2x, because 2 minus 1 is 1, and 1 we normally don't write it. And then this one, negative 2 times a 9, that's negative 18. Okay, x, and negative 2 minus 1, that's negative 3. We can rewrite this as 2x minus 18 over, remember, we can take the variable and make it from a numerator to a denominator. All we have to do is change the negative to a positive, just like that. And that is our final answer. How many marks? 3 marks. Down in the bag. All right, let's do the next one now. The next one, g1 of x if g is that. Okay, that's cool. Let's take that g. This is 8.2.2. G of x we are given is square root of x plus 3, and then square root of x minus 1. All right, that's cool. Let's give ourselves much space. And then what we're gonna do here, I like doing this. I do it all the time, and I suggest you should do it too, because under exam stress, you never know what mistakes you're gonna do. So square root of x times square root of x gives you x. Square root of x times minus 1 is minus square root of x. And then here I have plus 3 times square root of x is just 3 square root of x. And then 3 times -1 is just minus 3. Okay, let's see what we can do here. So if we simplify this, we're gonna have x, and I got a negative square root, -1 square root of x plus 3. So that's like saying 3 minus 1. So 3 minus 1 gives you a positive 2. So it's a positive 2 square root of x, and then minus 3. Now, because we're going to differentiate, we still want to simplify this further, because we don't want a square root sign. So we need to convert a square root sign into an exponent. The square root is just a half. I hope you know that square root is just a half, represents a half. So it's an exponent of a half. So now when we come down to do g1 of x, it's gonna be equals to, we bring the 1 down, we don't need to write it, and then or maybe let's write it, and then x1 minus 1 is 0. So any variable to the power of 0, it gives you 1. So this becomes 1. And then this one, the next one, what we want to do is just bring that number down first. Okay, so it's a half times that 2 x, rewrite it exactly as it is, x to the power half, and we want to subtract 1. Okay, and then this one minus 3, you can never differentiate a number. Okay, so it's just gonna be minus 0. Okay, now let's do this. Let's knit this up. So it's 1 plus this 2 will cancel that 2, and then you're left with x. And then what is a half minus 1? Yes, you guessed it, it's minus a half. Half minus 1 is minus a half, and you want to make it neater, so it becomes 1 plus, remember what I said about a negative number, that's a numerator, it can come to the bottom and be a denominator, but the half must now be positive. Okay, and a half, we already know a half represents square root. So this is our final answer right over there. That's it, ladies and gentlemen. We're done with question 8. And so good. I hope you understood. Thank you so much. Well, good day to you. I hope you're having a fantastic day. Well, welcome to MV Tutors. My name is Figure, and we are doing the June 2021 paper 1 mathematics past paper. Okay, you just wrote this a few weeks ago, so I hope you're catching this at a time where you are able to follow and you have studied, and this is just extra work. But in any event, if it's not, you are at the right place. You came to the right place for this memorandum. English sometimes. Okay, so let's get right into it. It says the graph of f of x, this one that's given, is sketched below. A and B are turning points. Where's A? There's A, and that's B. I see it. Thank you. And then point C is 2 and 4. All right, I see them. Okay, now let's get right into the questions. 9.1, determine the coordinates of A and B. Now, you need to know a few principles in order to answer this. First of all, you must know that turning points, to get the turning point, you need to get the x values, rather, you need the x values are equals to the first derivative. And then what you do is you equate it to 0 and then solve, and then you solve x. That's what you do. Okay, so you take the first derivative, equate it to 0, solve for x, and then you'll get the x value of the turning points. Now, to get the y value, you need to substitute it back to the original equation. So let's start with the original equation. F of x, we have been given as 2x cubed plus 3x squared minus 12x. Simple as that. And then what we want to do now is do the first derivative. I hope by now you know how to do the first derivative. So the first thing is bring the 3 down, and then it's gonna be times, rewrite it exactly as it is, and then subtract 1 from the exponent. For this one, you do the same, you bring the 2 down, and then you write it exactly as it is, which is 3x2, and then minus 1. And then this last one, do the same thing. It's 12, and then you're gonna have x1 minus 1. Okay, so let's simplify it further. What's 3 times 2? If you said 6, you're right. So this is 6. And then what's 3 minus 1? If you said 2, that is correct. 2 times 3, that's 6 again. And then what's 2 minus 1? It's 1. You said it. And then this one, minus 12. What is minus 12? What is 1 minus 1? It's 0. Okay, so x to the 0 to the power 0 is always going to be 1. So this is our f of x. So what did I say? I said you must equate it to 0 and then solve for x. Now, if you look at this question over here, this is what we have here now. Let's just deal with this. You can see that we need to solve for x. We need to solve for x. So there are many things you could do. And maybe to simplify it further, let's do this. Let's actually divide everything by 6. Divide by 6, because these are factors of 6 if you look at them. And then you're going to have 6 divided by 6 is 1. So this is x squared plus 1 minus 1x. I want to write that x. So instead of 1x, I'm just going to say x. 12 minus 6, that's 2. Okay, so we can factorize this. Nice. It looks nice and factorizable. So open 2 brackets, put x on each. Now we need a number that we can multiply, and it gives us 2. It's only 2 and 1. There's no other one. So we'll put 2 and 1. Okay, and then we ignore this number. Then we come this side then and say, okay, how can we get a positive 1 using 2 and 1? If you said you must say 2 minus 1, then you are right. So then 2, we put a positive, yeah, and then minus 1, that's a negative, right? So what does this mean for us? This means that actually our x values are equals to -2. Okay, and then we have another one, x value, which is equals to 1. Okay, so all we have right now are just the x values. We need the y value so that we can get the coordinates, because you see they ask for coordinates. Coordinates are always in terms of x and y, and to get the y we need to substitute. So let's start with f of -2 into the original equation. I need to have the original equation somewhere. There it is. There. Okay. So the original equation is 2. Starts with the 2. And then there's a x, we'll substitute a -2. Like that. Squared plus 3. And then that x, we'll put -2. Squared. Did I say squared for the cubed? Yeah. Anyway, it should be cubed, not squared. -2. Okay, so we'll put this in a calculator. And then while we're at it, let's just write the other one as well. It's going to be f of, we'll substitute 1 to the original equation. So it's going to be 1 cubed plus 1 squared minus 12 times 1. Alright, let me grab a calculator real quick. So I will come down here. There is our calculator there. Okay, I hope you have the same calculator, because this is the calculator you should be using. Okay, so first we put it exactly as it is. We'll put a 2, open a bracket. Let's put a -2 in there. We close it, and it's cubed, so to the power 3. Come down here, and then we'll say plus 3, open the bracket, put a -2 in there, close the bracket, and square it. Fortunately for a square, it's already there. And then we say -12, open a bracket, okay, put a -2 in there, close the bracket, and say equal. So 20. We're gonna write 20 there. Okay, I'll remember it. It's 20. Just want to do the next one. So this one is gonna be 2, open bracket, it's a 1. A 1 cubed is still gonna be 1, so I don't really need to put it, but I'll put it for simplicity, because some of you actually want to see this. Okay, 3, 1. 1 squared is still gonna be 1. I don't need to put it, but for simplicity, let me just do the right thing. Okay, so this one is -7. Okay, thank you, calculator. This is -7 here, and it was 20. So what does this mean? It means if you look now at the coordinates, you want to write your coordinates. Coordinates are in terms of x and y, and it's a and b. Okay, so which one would be a? If you said a is the one on the far left, you are correct. So the one on the far left is the negative number. So a is this one over here, which is -2 and 20. Okay, and then b is this one over here, which is 1 and -7. 7. Okay, that's it. It's 5 marks. You can put it here if you want. Let me just put it out of curiosity. So this point here, I'll put it in black. How about that? A is, what did we get? Was it -2? I think so. -2 and 20. That's A. And then B was 1 and -17. Is that right? -7, not 17. Okay, it's just -7, like that. Okay, it's just for perspective. So now they say, for which values of x will f be concave up? Okay, do you remember the difference between concave up and concave down? If you don't, let me remind you. Well, concave up is if it's like that. This is up. So it's concave up. Concave down is when the graph is going like down, like that. So they are asking us for up. So we are looking for this situation here where it's going like this. But where does it start going up? The graph starts going up there at what we call the point of inflection. Okay, so from the point of inflection to infinity, that's where it's going up. It's shaped like a U, which represents up, as you can see. Now that means we need to solve for the point of inflection. Okay, so in solving the point of inflection, POI, okay, basically what we do is that we need to derive f of x twice, equate it to 0, and then solve for x. That's it. Okay, so let's do that. First of all, did we solve? We solved here f1 of x, and we got, I don't know if I should, let me use the original one, which is, I'll keep it there. So we have f1 of x as 6x squared plus 6x minus 12. Okay, so which means f2 of x then is, we bring the 2 down, times, we left with 6x squared minus a 1 there. And then the next one is 6, bringing a 1. 1 minus 1 is 0. Any variable to the power of 0 is just 1. So that's what we have over there. Okay, let's complete it. 6 times 2 is 12. X, because 2 minus 1 is that. 2 minus 1 is that, and then plus 6. So equate it to 0 and solve for x. So in solving for x, if I take the 6 to the other side, it becomes a minus 6. And then divide both sides by 12 so that I get rid of that 12. Therefore, my x value is equals to minus a half. Okay, because minus 6 divided by 12 is just purely minus a half. Okay, so let's go put that in the equation so that we can see this perspective. Now what we have here is that the x value here is actually minus a half. Okay, so it's concave up from minus a half. For which values of x? From minus a half to infinity. Okay, so let's write it like this. So the values of x that we are talking about here is, put the x there, put this is one way, right? And on the left we have minus a half to infinity. Does it include a half itself? Include a minus a half? No, so it's not equal to minus a half. Okay, this is one way of writing it, or you can write it like this, where x is an element of open a bracket, a circular bracket, put minus a half here, and when you write infinity, it's always also with a circular bracket. Always infinity, negative infinity, always a circular bracket. Okay, so there we go. Right, let's check the last question then. It says determine the equation of the tangent of f at c. All right. So now what do we know about tangents? Okay, so the equation of the tangent is always equals to f1 of x. Okay, so do we have f1 of x? F1 of x is equals to, yes, we have it there. Let me rewrite it again. Squared plus 6x minus 12. Right, now if we want to know the tangent at that point C, which is at 2 and 4, okay, remember a tangent, let me just tell you this, a tangent is in this form, which is a straight line. It's in this form. Oh, sorry, couldn't see that. It's in this form of y is equals to, so that's our x value there, that's our y value, but it's equals to mx plus c, where m is the gradient, okay, and then c is the y-intercept. Now that's what we are looking for. So right, in looking for the tangent gradient, okay, I should actually add that word there, the tangent gradient. The tangent gradient is the one that's equals to the f1 of x. So the gradient at 2, okay, so f1 at 2, because remember our point is, let me demonstrate it here. So let me just draw the gradient so that you can actually visualize it yourself. The gradient is over here, okay, it's like that. That's our gradient line at that point. So gradient can be at any point. I mean, the tangent can be at any point, but we want the tangent at 2, that point there, exactly that point. Okay, so to get the gradient of this particular line, which we need f1 of x, and then we just substitute the x value. Okay, the gradient is at that point. We just want the x value. So let's come back and substitute. So we're gonna have 6. We're gonna have 6. Where there's an x, we put a 2, so it's gonna be 2 squared plus 6. We'll put a 2 there. minus 12. Let's bring in a calculator. Gonna need a calculator for this one. So we have 6, open bracket, we got 2, you close, square that, plus 6, open a bracket, put a 2, close it, minus 12. Okay, and then we get 24. Thank you so much. So this is equals to 24. What's this 24? The 24 is the gradient. Okay, so that means our equation is now y is equals to the gradient, which is 24, x plus c. Now we need to solve c. To solve c, we need a point where the gradient, where the tangent is passing. So we definitely know it's passing 2 and 4, so we're gonna use that. All right, so we're gonna say I'll put 2 and 4, and then I like to put x on top and y so that I don't get confused. Under exam stress, it's very easy to miss these things, because what this means is that where there's a y, I must put a 4, so there's y there, there's a 4, and then 24 here, and where there's a x, I'll put a 2, so I must have a 2 here, and that's plus c. Okay, now to complete this, if I take leave a c this side, there's a 4 there. If I take this 24 to the other side, then it becomes minus, what's 24 times 2? 48. It becomes minus 48. That 4 is positive, so I'll put that plus. So what's minus 48 plus 4? That's minus 44. That's my c. So then to complete the tangent equation, the tangent therefore is equals to or rather, let me not say equals to, let me put semicolon. That's the tangent then for is equals to y is equals to 24x minus 44. And that, ladies and gentlemen, is our final answer. Well, I hope you understood everything. But in the event that you didn't, you know what to do. Just contact us and we'll be happy to tutor you in these matters. Thank you so much.
Hello everyone, welcome back to MB Tutors. I'm Tsulu and I'll be looking at question 10 with you guys. Okay, so let us get started. Now, the graph of f of x, ax cubed plus bx squared plus cx plus d has two turning points. Okay guys, this is a cubic function, okay? For those who remembered or who don't, this is a cubic function. That's a positive, I almost said happy face. That is a positive cubic function. And then you have the other one like this, which is a negative. How do I know the difference between the two? The end part is a happy face. And then for the negative one, the end part is a sad face. Okay, yeah, that's how I crammed it. How I know which one is positive and negative. So we have a cubic function. We don't know whether it's a happy face one or a sad face one. Okay, but it has two turning points. That is true. So now they've told us that f of 2 is equal to 0. Okay, guys, what does that mean for you? If they say the function where x is 2 is equal to 0, doesn't that remind you of an x-intercept? Okay, remember that the x-intercept, that's really where y is equal to 0. So f of whatever, f of 2, that's like your y value. This is another way of saying y. We know that y is 0, but where is y 0? it's 0 where x is 2. Okay, so I think let's just have an xy axis, okay, and just see where it takes us. Just populate what we know and take it from there. Okay, so this is your y-axis and that is your x-axis, and life is good. So this is 1 and that is 2. So we know that we have a point there. Okay, awesome. Now the x-axis is a tangent to the graph at x is equal to -1. Okay, -1, -2. The x-axis is a tangent. Okay, so if it is a tangent, guys, there are two options. Either the let me just go back. It has to be a tangent, right? So either you have it, why is it so difficult to draw? You have something like this, okay? Or you have something like that. Okay, those are two options. Let's read further. Okay, then the first derivative, okay, is equal to 0. Remember, with cubic functions, if you're going to work out the first derivative, let me just write it over here. So if you're going to have the first derivative, okay, equal to 0, that is actually your gradient, okay? And it's also where you can get your turning point, okay? Remember, whenever you want to determine the turning point of your cubic function, you first determine the first derivative, you make it equal to 0, and then you get the x value. Then after getting that x value, you substitute it in the original equation to get your y value. Okay, so now they're telling us that there's a turning point at 1. Okay, all right. So somewhere, there's a turning point. So this turning point, we don't know what the y value is, but if we were to have, okay, so we have turning points at 2 places, guys. We have it at 1 and -1. Okay, so it could be like a turning point somewhere here, or it could be a turning point somewhere there. Okay, what will actually help us to know what this graph is actually looking like? Is it a graph that's actually gonna, let me just choose a different color. Will it do something like this? With this option here, or will it do something like that? Okay, let's find out. Now they tell us the first derivative at half is bigger than 0. Okay, guys, remember, when you're getting the first derivative, that's actually your gradient. Okay, so here they're telling us that the gradient at a half, it's positive. Okay, the gradient is positive. A positive gradient does this. Okay, a negative gradient does that. Okay, so this is negative m, that is positive m. Okay, so we already now know, we're looking at this option here. Okay, it can't be that one. Okay, so we already know now we can't have this option and we can't have that option. Okay, and yeah, so that's -1. Okay, but that's not all, guys. Also, when you have this first derivative, that actually gives you the point of inflection as well. Remember the point of inflection? The point of inflection, if you have your graph, no, what am I doing now? I'm putting 3 turning points. If you have your graph like that, let me just redraw it. The point of inflection is somewhere there, but how do you know that it is a point of inflection? Well, basically, that's where you change from concave down. Okay, this is concave down. You can see it's like it's caved downwards. Okay, that's where you change from concave down to concave up. Okay, so that change from concave down to concave up, that is signified by the point of inflection. Okay, that's where you know there's a change in concavity. All right, so yeah, whether it goes like this, again, where you go concave down to concave up, it doesn't matter. But basically, the point of inflection is where you have a change in concavity. All right, so having said all of that, we know that at a half, that's where we have our change in concavity. Okay, so we have our change in concavity there. We have our turning point there. We have our second turning point. I'm just going to remove that so that we can draw a nice graph, hopefully. Yeah, sometimes it's just better when you draw on a paper because wow, the things that come out. Okay, so I'm going to draw this graph in green or maybe black. All right, so we have our graph. It goes down, makes a turn there. Then it changes concavity there. Oh my gosh. Yo, guys, I'm struggling. I'm struggling to draw this graph. I really am. I'm normally good at drawing, but yo, I'm seeing flames. Okay, so okay, we have our 1 there. We know we have our turning point. Let me try to make it more flatter. So we have our, let me just draw. We have our turning point there. We have our point of inflection at a half. And then we have our turning point that side. Okay, I'm just going to leave it at that before I embarrass myself further. But that's basically it. So you have your turning point here, which is 1 and whatever y value. Then you have another turning point. Let's just assume that -1 is there. Okay, so you have another turning point where it's at -1 and 0. Then, we have our, oh, my bad. I forgot about the x-intercept. Okay, so we have our turning point here, and then, yay, it went through the turning point. I mean, the x-intercept. And yeah, okay, so they said we should show the x-coordinates. Yeah, only indicating the x-coordinates of the x-intercepts. Yes, so the turning point was not necessary. That's extra information. Okay, so I'm gonna just leave it there. But yeah, you can indicate there that that is your point of inflection. Okay, they didn't really ask for it, but I guess when you give them more information to show that you understand, you'll get like recognition. Maybe not in the form of marks, but they'll be like, yeah, hey, this kid is good. They know their stuff. All right, now we get to 10.2. It says O is the center of a semicircle, okay, passing through A, there's A, B, C, and D. The radius of the semicircle is x minus x squared units for x between 0 and 1. Triangle AOB is a right-angled triangle. Awesome. Okay, so they, you know that rule in paper 2 where it says that if your chord is a diameter, never mind, this is not it. This is not it. But basically, the one that I was actually trying to refer to, if you have a diameter as a chord and you have lines that are touching the circumference, forming a triangle, then you have a right angle triangle. My bad, this is not it here. And we're still in paper 1, so let me not jump the gun. But they told us that the radius of the semicircle is x minus x squared. So basically OD, okay, is x minus x squared. OC, x minus x squared, okay? Basically. And then guys, do you realize that OA is also a radius? It is. So OA is also x minus x squared. And OB is also a radius. So again, x minus x squared. Okay, so it's good to write these things down. Now they say show that the area of the shielded part is given by pi minus 2 over 4 multiplied by x to the power 4 minus 2x cubed plus x squared. Okay, guys, so we want the area of the shaded portion. Where do we start? I mean, I can already calculate the area of the triangle. It's a right angle triangle, half base times height. We're good to go. But my goodness, how in the world are we going to get this? Okay, let's think about it. We have a 90-degree angle. They didn't just put there for fun. It was to help us. Let me put a full circle. Sure, what's happening today? Okay, let's try it again. So, full circle. Okay, we know that a full circle, okay, a revolution is actually 360 degrees. If I were to go all the way around, that is 360 degrees. Okay, now, if I were to divide this circle in portions, let's say I'm going to put quarters to it. Okay, half. Let's start with a half. If I have a half, then I know that is 180, right? If I half it again, I know I have 90 degrees. So this portion here, oh, another thing, my circumference. My circumference is 2 pi r, or I could say pi d. There I go. Okay, my circumference is pi d. Okay, if I wanted the circumference here on one of the quarters, okay, that's going to be pi d over 4. Okay, let's talk about areas. The area of a circle is pi r squared. Okay, if I want just for the quarter, what that area is, that's going to be pi r squared over 4. Are you getting where? Yeah, are you seeing where I'm going? Rather, are you getting me? So basically here, okay, now I'm butchering this. Okay, basically, I have a quarter of a circle here. And what confirmed that I have a quarter of a circle? But basically, the fact that they told us that it's 90 degrees. Okay, so I can already get the area here. Okay, and the area there, it's just going to be the area of a circle divided by 4. Okay, and once I have that, I already know or can calculate the area of a triangle. Okay, and once I have the area of the triangle, I can then take the area of that quarter of a circle, subtract the area of a triangle, and then I'll get that area of the shaded part. And pray to God that I get this, because if I don't get it, then I'm in trouble. Okay, so 10.2.1. So the area of the quarter of a circle, that's actually equal to pi r squared over 4. Okay, and then the area of the right angle triangle, it's actually equal to half base times height. The base and the height, so this is the base, which is the radius, this is the height. Again, it's still the radius. So it's actually equal to half, actually, r squared. Okay, and then the area of the shaded, let me just write it this part. The area of the shaded part, okay, I'm just going to shaded part, it's actually equal to the quarter pi r squared over 4 minus r squared over 2. Okay, we're getting somewhere here. So I want them to have a common denominator. So I will have 4 there, and I have pi r squared minus 2r squared. Okay, why is this eraser so big? Okay, so I have 2r squared. Okay, because I had to multiply the denominator by 2, and I had to also multiply the numerator by 2. Okay, now I can take, this is guiding me, actually. I can take the common factor out, which is r squared. I take r squared out, I'm left with pi minus 2 over 4. Okay, so I already have the first part. Now, let's get the second part. The r squared, they already told us what r is. R is x minus x squared. Okay, so I have x minus x squared, and that is squared. Okay, so I'm just gonna put it like that again. Okay, and then I have my pi minus 2 over 4. Okay, so yeah, x times x, that'll be x squared minus x cubed again. Okay, so that's going to be minus 2x cubed, and then I'll have plus x to the power 4. Okay, are we getting there? And all of that is multiplied by pi minus 2 over 4. Okay, so let's see, in what format did they put it in? So basically this portion has to come first, and then we're putting our polynomials from the highest degree first. Okay, so yeah, but basically we have the answer, guys. It's all good. So final answer, pi minus 2 over 4 multiplied by x to the power 4 minus 2x cubed plus x squared. And we have shown. Okay, so we are good. Now the last question. 10.2.2, determine the value of x for which the shaded area will be a maximum. Okay, this is where we put differentiation into practical use. Okay, so now if we want to get the maximum, whenever they want the maximum or the minimum, we will have to determine the first derivative. Okay, so basically you're going to take that area and get the derivative of it. Okay, so we have a constant here. Okay, so I'm just going to keep that constant as it is. Minus 2 over 4. If you wanted to complicate your life, you could you could multiply this constant in every term. Okay, but that wouldn't help much because yeah, you would still take out the common factor, which is this constant. So let's just leave the constant out and then perform the derivative calculations. So first of all, x to the power 4, we know that the 4 comes down, and then we subtract by 1 on the top. So 4 minus 1, 3. Then we're going to have that negative there. We're going to bring, well, here on the second term, we're going to bring the 3 down. So it's 2 times 3, which is 6. Okay, x, and then 3 minus 1 is 2. And then lastly, we have x squared. So we have just 1 there. So 2 times 1, that'll be 2. And then x, so 2 minus 1, that's 1. We don't even need to write that down. Okay, so yeah. Okay, but we're not done. Remember, getting the first derivative, making it equal to 0, because we need to solve for x and get the maximum value of the area. Alrighty, so now we have a constant here, guys. We can take it to the other side and it's going to be 0. Okay, so I have, I also have a common factor. So taking this value over here to the other side, that'll be 0. Okay, so I'm left with 4x cubed minus 6x squared plus 2x. Okay, so I can take out a common denominator, which is 2x. Okay, if I do that, I am left with 2x cubed. Okay, then I'm left with minus 3x. And then I'm left with 1 here. That is equal to 0. Okay, I'm going to further break this apart. Factorize it is the right term. So I have 2x over there. Now you can use the quadratic formula to perform this calculation if you can't just see straight up what the answer should be. I normally do a trial and error. So I know I'm going to need 2x and I'm going to need x here. And because this last term is 1, I'm going to have 1 and 1. But what will actually give me minus 3? Okay, so if I multiply 2x times 1, that'll be 2. And if I multiply 1 times x, that'll be 3. Okay, so it's a negative here. I'm going to put negatives on both sides because my last term is a positive. Okay, if my last term was a negative, I was going to have to put a positive and a negative. But because the sign there is positive, negative and negative do give me positive, and negative minus negative will be minus. Okay, so yeah, now my answers. So I have 2x is equal to 0, or I have 2x is equal to 1, or I have x is equal to 1. So my first option, it's actually going to be x is equal to 0. My second option is going to be x is equal to a half. And my third option is x is equal to 1. But which one is it really? I need to go back to my original equation, okay? My original equation, which is the area of the shaded part, that original equation is pi minus 2 over 4. And I had x to the power 4 minus 2x cubed. Okay, minus 2x cubed plus x squared. I need to substitute these values in here, and whichever will give me the maximum, that is the value that I'll take. So let's put 0 for 1. If I put 0 in here, okay, I'm going to get an area. Let me just write it there in black, probably. So for x is equal to 0, I'm going to get an area of 0. Okay, because this whole term here is going to be 0, and if I multiply 0 by this constant here, it's going to be 0. Now if I take this whole term and put and substitute a half where x is, I'm going to get a value, right? If I substitute 1, I'm also going to get a value, but my maximum value that I'm going to get will come from 1. Okay, let's test it. Let's see. So I have pi minus 2 all over 4. Okay, and that is, okay, so I'm going to substitute a half. Okay, 0.5 to the power 4. Okay, and then minus 2 times 0.5 to the power, okay, to the power 3. And then plus 0.5 squared. Okay, so that answer there is 0, I'm just going to say 0.02. So the area here is 0.02 units squared. Okay, then lastly, if I substitute 1 in there, okay, so I'm going to go back. No, yeah, I'm just going to put 1 where there was 0.5. Okay, 1, and our answer, what? 0? Really? Okay. Wow, I was expecting it to actually work out. Okay, so I have 1 squared, yes. 2 times 1 cubed. And wow, okay guys, so the answer is 0. Yo, good thing we did a check. Because if we didn't, my goodness, I would have just assumed that because it's 1, that things work out. So finally, when you write your answer, guys, the answer cannot be equal to 1, nor can it be equal to 0. The one that will give the maximum area is actually x is equal to a half. Okay, what was the question again? Did they want the value of the area? Okay, determine the value of x. So it's actually a half. It's good to do your checks, ne? Okay, guys, so this is it for question 10. Thank you for tuning in. I hope you learned something. And I hope the preparations for your supplement, no, not subs, your prelims. Yes, I hope the preparation for your prelims is going well. Okay, thank you. Alrighty, hello everyone, and welcome to our YouTube channel, MB Tutors. I'm Tolo, and we are still looking at the prelim that was written in June. Okay, so I'll be looking at question 11 with you, and let us get started. Alright, so they tell us that two events, A and B, are such that events A and B are independent. Okay, that's already a hint there. So we have independent events. That should already be telling me something. Okay, then they say P not A is 0, 4. Okay, so yeah, you have complements there. So you have not A and then you have A. Okay, and then the probability of B happening is 0, 3. Now they want us to calculate the probability of A and B. Okay, so I'm just going to write it here on the side. So for 11.1, first of all, they told us that the events are independent. And you know that independent events, okay, there's a formula for that. Okay, so independent events. Okay, so we have independent events. What do we know about independent events? We know that probability of A and B is equal to the probability of A times the probability of B. Okay, then they told us again, we already have the probability of B, right? They gave it to us, which is 0, 3. But now, what is the probability of A? So they told us that the probability of not A will be equal to 0, 4. Okay, meaning that if you want the probability of A, I told you guys that the two are complements. So probability of A and probability of not A, that should give you 1. Okay, now we already know that the probability of not A, it's actually 0, 4. So the probability of A will be 1 minus 0, 4, which will be 0, 6. So now we know the probability of A is 0, 6. Now, to eventually get the answer, just going to move slightly up. We know that the answer now, probability of A and B is actually equal to 0, 6 times by 0, 3. Okay, and I think that will give you 0, 8. Okay, so yeah, we are done with calculating the probability of A and B. So let's go ahead now and see what 11.2 wants from us. So it says a survey was conducted among 150 learners at school. The following observations were made. The probability that a learner selected at random will take part in only hockey is 0, 24, and we can see it there. 0.24. Okay, just hockey. And then hockey and debating, but not chess. So hockey, debating, but not chess. So that's 0.14. Debating and chess, but not hockey. That is going to be 0.12. Hockey and chess, but not debating, and that is 0.02. The probability that a learner selected at random participates in at least one activity is 0.7. Okay, so just bear in mind that, well, yeah, you can say the complement of that would be 0.3. If no one is participating, if they were to choose someone at random who's not participating, then we're looking at the complement of 0.7. So that would be 0.3. Okay, 15 learners participated in all 3 activities. So if it's all 3 activities, we're looking at this intersection of all 3 events. Okay, the number of learners that participate only in debating is the same number of learners who participate only in chess, and that is why you have B there and B, because the value is the same. All right, so what are the questions? So now we see here the Venn diagram below shows some of the above information. Okay, so now if we were to look at this closely, just gonna choose a different color. So the sample size there, okay, it's actually 150. Okay, but because here we are using, oh, it's actually the same. Because here we are using probabilities, it will be actually equal to 1. But we know that in actual fact, we have 150. Okay, and then, yeah, oh, let us have a look at the question. So this is the information. Now let's see what the question says. So question 1 says, determine A, the probability that a learner selected at random participates in all 3 activities. Okay, remember they said 15 learners. 15 learners are participating in all 3 activities. That's the intersection of all 3 activities: hockey, debating, and chess. Okay, so in that case, then, if we want the probability, 11,21, so we want the probability of A, that'll be 15 over the sample size, which is 150. Okay, and I can see there, if I say 15 divided by 150, that's actually going to be 0.1. Okay, that's just 10%. So that will be the probability that a learner selected at random participates in all activities. Now, determine M, the probability that a learner selected at random does not participate in the 3 activities. Remember, this part here. The probability that a learner selected at random participates in at least one activity, that is 0.7. Okay, so the probability that they participate, that's 0.7. Okay, and if they don't participate, so I'm just gonna indicate it like that. If they do not participate, then that'll be 1 minus 0.7, and that'll then be 0.3. That'll be the probability. Okay, so M, the probability that a learner selected at random does not participate, so that is 0.3. That is your answer there. Okay, and then 11.2.3, how many learners play only chess? Okay, let's go back. All right, so the ones that play only chess, that's B, which is equal to those who play or who participate in debating. All right, so I just wanted to fill up this Venn diagram with actual values. All right, so we know that those that do not participate, which is M, the probability is 0.3. Okay, then we're looking for B. And A, we've already determined that A is 0,1. So if I were to attempt to redraw this Venn diagram, okay, let's see. But this time I'm using values and not probabilities, okay? So I would have hockey here. Ooh. Okay, let's try again. You know what, let me just do it. Doesn't have to be perfect. So we have hockey, and then we have debating, and then we have chess. Okay, so A, we already determined that it's 15, okay, which was 10%. So we have 15 in here. And then we have our sample space, which is 150. Okay, and we know that those that are not participating, that'll be 0,3 times 150. Okay, I'm going to use the calculator. Okay, so we have 0,3 times 150, and that is 45. So I know those who did not participate, 45. Okay, then I'm going to look at 0.24. Okay, let's head over there. 0.24 times 150, that is 36. Okay, so 36 over there. And then 0.02. Okay, 0,02 times 150, that is 3. Okay, and then 0,12. All right, guys, I know this is a little bit tedious, but yeah. So that is equal to 18, and then 0.14. 21. So that is 21, and that is 18. Okay, guys, and we know that that's B and that's B. So if I add all of these values up, I need to get 150. Okay, so let's see. Okay, so I have 36 plus 15 plus 18 plus 21 plus 3 plus 2B plus 45. Okay, don't forget that 45 there. And that is equal to 150. Okay, so what is 2B equal to? Okay, so I have 36 plus 15 plus 18 plus 21, 3, 45, and that's equal to 138. So if I say 150 minus 138, I get 12. Okay, so cool. I have 12. So B is 6. Okay, if you want to know the actual percentage or the probability, you would say 6 divided by 150. Okay, so if I were to have 6 divided by 150, then it would be 0,04. Okay, so yeah, that would be 0,04. Okay, for both, yeah, 0,04. But they wanted the number of people who are only playing chess, and that is 6. Okay, can say 6 students. Alrighty, now let's look at the other. Oh yeah, learners that only play chess. We already answered that. That is 6 of them. And now 11.3. A 3-digit number is made up by using 3 randomly selected digits from 0 to 9. Okay, and they say that no digit may be repeated. So I have a 3-digit number. Okay, that's spaces for 3 digits. Okay, so if I were to choose, remember I have a choice from 0 to 9. So I can choose 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. And you know, these are 10 digits. Okay, so if they didn't make any rules apart from saying that no digit may be repeated, and they just said how many possible codes would you have? Okay, oh yeah, how many? Yes, how many codes would you have? 3-digit numbers would you have? Your first option, you would have 10 options, right? But now you can't repeat, so you'll have 9 on the second one, and because you can't repeat, you'll have 8. If repetition was allowed, guys, then you would have 10 options on the first, 10 options on the second, 10 options on the third. So that's just the difference. Okay. But now let's listen, let's read and see what it is that they want. Now they say determine the total number of possible 3-digit numbers greater than 100 that can be formed. Okay, so I have 3 spaces available. This has to be greater than 100. Okay, guys, if it's greater than 100, the options here, okay, actually, let me do it this way. If it's going to be greater than 100, I cannot choose 0. Okay, because if I choose 0 as my first digit, yeah, I cannot choose 0 as my first digit. Because if it's 0 here, then it means the rest will be less than 100. So I have to take 1 up until 9 for my first digit. Okay, so I have only 9 options for the first digit. Now, for the second one, I can have 0. Okay, I can have 1, I can have 2, I can have all of them. But I have, okay, so let me put it this way. I have 10 digits at my disposal for the second option. But because no digit may be repeated, I now actually have 9. Okay, I don't have the whole 10. I have 9. On the first digit, I was restricted. I could not use 0, so I only had 9 at my disposal. Okay, second one, I could have had 10 if repetition was allowed, but I can't. I only have 9 options available because 1 has already been used up. So I've used up 1 here, I've used up 1 there. The third digit, I only have 8 to my disposal. Okay, because I've already used up 1 here, 1 on the second one, so I only have 8 digits left because repetition is not allowed. Okay, so if they say determine the total number of possible 3-digit numbers greater than 100, that value would be 9 times 9 times 8. Okay, so let's just calculate quickly. I'm not even going to try to calculate it in my mind. Okay, so the answer is 648. Those are the possible numbers that we have there. All right, and then 11.3.2. Determine the total number of possible 3-digit numbers, both even and greater than 600, that can be formed. Okay, so we have our 3 spaces available. Now, they told us that they have to be greater than 600. Okay, so if it's greater than 600, I can't use 5 as the first digit. Okay, I can use 6 up to 6 up to 9. Okay, so I have 4 options available there. All right, and then they tell us that it has to be even. Okay, so we have 2 restrictions, guys. We have restrictions on the first digit. We have restrictions on the third digit. They told us that both, they could be, it must be even. So it means your last digit must either have 2, 4, 6, or 8, or 0. Okay, so I have 5 options. But guys, here's the trick. What if, okay, so like we said here, we have 6, 7, 8, and 9. What if I decided to use 6? If I decided to use 6, 6 is an even number. I don't have 5 options anymore. I'm going to have 4. Okay? If I decided to use 8, again, I'll have 4. So this becomes a little bit complicated. We need to break it down. Okay? I can't just use like I did on the first question, 11.3.1. I can't just calculate it straightforward like that. I need to break it down. Okay? So let us attempt breaking it down. So, in the first case, I would have 6 as an option. Okay? And then, yeah. In the second case, I would have 7 as an option. Third case, I would have 8 as an option. And then the last case, I would have 9 as an option. Okay, so in each case, then I have one option for the first digit. Okay, can either be a 6, a 7, a 8, or a 9. Okay, now we can go to the even side. Okay, the third digit there. If I were to use 6 on the first digit there as an option, I only have 4 options at my disposal. So I could either have a 2, 4, 8, 0. So I would have 4 options to choose from here. Okay, I know I've been skipping the the middle term. Basically, if I took one option here and I have 4 options, but I can only choose one number, right? Then I have 1 here, I've taken that, I have 1 also at the last, then I have 8 that are left. Okay, because they cannot be repeated. So I can only use a number once. Okay, so 8 options will be left for this middle digit. Same thing here. So now I have 7. If I use 7, which is an odd number, I have all 5 even numbers at my disposal. Okay, I can use them. So I have 5 options. Okay, but I can only choose one from them. Here I only have 1 that I've chosen, so I will have 8 options left for this middle term or this middle number. Okay, if I choose 8, again, I'll only have 4 options to choose from because I would have 2, 4, 6, and 0. Okay, and again, the middle digit will be 8 options available for that. And here, 9, which is an odd number, I have 5 available options, and here I have 8 available options. So then, for us to determine how many options are actually available, okay, there I started writing and then I forgot. Okay, so if I multiply all of that, for A, I'll have 1 times 8, which is 8, times 4, which is 32. Okay, 8 times 5, that'll be 40. 8 times 4, still 32. 8 times 5, that is 40. Okay, so I need to just sum all of those numbers up. So then I have 64 plus 80. Okay, and that is equal to 144. I didn't want to use the calculator here. Okay, so I have 144 possibilities, okay, for having 3-digit numbers that are both even and greater than 600. I hope that you guys understood it. I hope you enjoyed this section. I think for those doing matric in 2020, because of COVID and the number of disturbances to the curriculum and school and holidays and all of that, I think they said they're going to remove the counting principle. I think. I'm not sure. You guys can confirm and comment down below. But I hope they don't remove it. It's quite nice. But if they do, for those watching, I hope you enjoyed learning something here. Okay. Enjoy the rest of your day. And yeah, please guys do tell us what it is that you would like for us to do, which papers you'd like us to do. Just comment down below, okay? And tell a friend about this channel if you know that they are struggling with maths and they can't afford to get a tutor, and this is like a way in which they can study. All right. Thank you guys. Bye.